participants 5. हाँ host me अभी दिखा रहा है.
So very good morning to all of you. May I request icon_2 to kindly make me co-host. I request the volunteers from IIT Patna to make me the co-host of this meeting.
Hello.
Hello, sir.
Yeah, hello, how are you? Good
Yeah,
morning.
I'm good. Yeah, good morning. So I didn't quite get what you just said.
I'm saying make me co-host as well.
Okay, okay. I'll do that.
Fine. And we can start, we can record the meeting as well.
You are now the host.
Yeah, thank you. So you also remain along with me.
Krishanu will be recording the session. Krishanu, have you started recording?
No. Okay, just I
Yeah, I
think
can start. I think we can start recording. Thank you.
the screen is not clear.
Yes, you were saying something. Yes, please come again.
Hello, share.
Yeah.
Actually, I have seen a rectangle black box in the middle of the screen.
Okay. Is it fine now?
Yes.
Okay, because I was looking at the participant list and I think that box will be coming on the screen.
Now it's okay, sir.
That's great. So we'll be starting shortly when the session chairs will be joining us. Fine.
Sure. Okay. So I have started the recording. Okay.
Even I have started the recording over here. Okay, thank you. Take
It's
care.
better to
Bye.
have copy also. Thank you, sir.
So this is for information that I have also make it live on the YouTube. So YouTube link I have already shared in the group.
Yes.
Yeah. We have already seen that. Yeah, thanks.
Arindam.
Yes, Krishanu.
Okay, when I just click on the record option, it shows that please request recording permission from the meeting host.
Okay. I think you have not joined as host.
No. I have started recording. I am now host. I am the host and I am getting the option of recording. I have started recording.
Okay, so I think I have to join as a host. Okay.
No. Okay, I am saying I have started recording from my side. No issue.
Okay. Then.
So very good morning to all of you. I welcome our session chairs, Professor Gurpreet Singh Lehal, Punjabi University, Patiala, Mr. Neeraj Kumar from Facebook, USA, Professor Sanjay Dwivedi, Central University, Lucknow, Dr. Rajeev RR from IC Force, and Mr. Sanjeev from Google Incorporation, Bangalore. So we are waiting for the first participant to join. I think Medari Tham has already joined. So if the session chairs allow, can we start the session, sir? Dr. Lehal, Dr. Neeraj.
Sure. Good morning. Sure, we can start.
Okay. Thank you. So nice of you. Thank you very much. So we are starting with the very first. So Medari ma'am, please you present your demo. So I invite Medari Thama to present the demonstration. It is on NLP Tools for Khasi, a law resource language. Yes, Medari ma'am. Am I audible to you? Hello, Medari Tham ma'am. Am I audible to you, please? Please unmute yourself. You are.
Hi, Vishal sir. Can you see if you can unmute her in case she's not able to unmute?
I am not able to unmute her. I just call her. Please, please unmute yourself. Yeah, ma'am. Please unmute yourself, please.
Hello, sir.
Yeah.
So, me?
Yeah. Please present your
Okay,
demo.
yes. There's some connection problem, I think, just now.
Okay.
I'll share my screen. 1 second.
Okay, I'll give you the rights. Do you have the shared screen option with you?
I'll just check 1 second. Yes, the share screen option is there.
Okay. Please share the screen and present your demo, please.
Okay, give me 1 second, sir.
Yeah, sure. So in the meanwhile, I request Dr. Preeti Dubey to keep your system ready for the demonstration.
Okay, sir.
I hope you can see my screen now.
Yeah, it's visible.
Okay. So this is a demonstration of Khasi. It is an Austro-Asiatic language. It's called low resource languages. It's a low resource language because till date I have seen only my own system being available online. So I hope maybe with future research we'll be seeing more tools for Khasi coming up. And it is an Austro-Asiatic language spoken in the state of Meghalaya, some parts of Assam and some parts of Bangladesh. So if you see here, I have uploaded 3 tools, 2 POS taggers and 1 shallow parser. And in this website, it is available online for researchers to test this tool. So what we can do is, I can enter a Khasi sentence. I've already kept one here. And then when you click on tag or parse, you will see the output of the POS tagger and the parser. Now the first output is a HMM POS tagger. So here, each word is tagged with the parts of speech. This parts of speech is actually following the BIS standard guidelines, and a proposed Khasi BIS tag set is already in place. So here we can see that the output of E Risa Isngap Jingroi. This implies Risa is listening to music. So what the HMM parser has done is that it has tagged each word according to the POS tag set. Now what I noticed with the HMM parser is that there are instances where it can recognize Risa as a noun phrase, and sometimes, in this case, it could not recognize that it is a proper noun. So in order to actually tackle these errors that I notice in an HMM parser, I took the help of a CRF suite, where I again send this input to the suite, and what it does was that it uses CRF as the base, where it takes into account word features. So by taking into account the word features of the language, so what it did was, by passing it to that tagger, I get this output now, where now it can recognize that Risa is a proper noun. And then the third output is actually a shallow parser. Why I call it shallow? Because at this junction, it can recognize only noun and verb phrases. That too non-recursive. According to Abney, these are all non-recursive. In other words, they do not contain each other. So it has recognized that E Risa is a noun phrase, Snap, which is listen, is a verb phrase, and so on. Now, the best part with these taggers is that it can also recognize homonyms, because in our language, just recently, I have finished the analysis of regarding the Khasi language, and I have come across, from my data itself, I've come across 560 homonyms just from my own data. While another reported work, they've only detected around 130 homonyms, but after this work, I could detect that we actually have around 560 plus, though with a very small corpus in place. With a bigger corpus, we can have a look at the homonyms. So I'll just show one more example. For example, if I write ulam, ukit jhur dakakho. Here it means this person Lam is carrying vegetables using a cone-shaped bag. So this kho is actually a homonym. It can function as a noun. It can also function as a verb. So when I tag here, if I click on tag, so what is happening? The parser, if you see here, both the taggers can actually detect that kho is a noun. It's a common noun. So ulam correctly here, you can see the HMM tagger here, it's recognizing lam also as a proper noun. So ulam ukit kho, that ukit jhur daka kho, carrying vegetables using a cone-shaped bag. Now in the same way, if I use another one, okay, here this is the second usage of kho as a verb. So here what is happening? Ki kho yakasini uding. They are peeling off the bark of a tree. Here, the HMM tagger has failed to detect that core is a verb. But the hybrid tagger, which I have incorporated CRF here, what is happening? It has recognized that core is actually a verb, functioning as a verb in this sentence. And likewise, the output of the shallow parser is based on the output of the hybrid parser. So thank you.
To please ask the questions.
Hello, Medari.
Yes,
I just have a few queries. First thing is, do you use Roman script for this language, Khasi?
yes, sir. We use Roman script, correct.
Okay, so no other script has been used since long, eh?
It's actually around 1900. Actually, we started using this script when the British mission, the Welsh missions, mission reached Shillong. It has a long history. Actually, we used Bengali script earlier, but then when the Welsh missionaries came here, they found that our sound system is similar to English. So they have brought in the Latin script. Of course, we don't use all the letters. Some of the letters have been removed and 3 new letters have been added to the Latin script that we are using right now. So currently we have around 23 alphabets.
Okay, so that's interesting. What new letters were added?
The new letters are the yi, the I with the diaresis, yi, and then the n with the diacritic again, and a digraph, NNG, it's a digraph. Those are the 3 letters. I can type here if you want to see.
Okay.
But those 3 letters are there.
Sure.
Else having any queries? Okay, so thank you, Medari ma'am. It was wonderful demonstration and appreciable task. So thank you very much. So we are moving to the next demonstration, rule-based Hindi to Dogri machine translation system by Dr. Preeti Dubey and Professor Devanand Padha.
Thank you, sir.
Yeah, please share your screen.
Yes, sir. Call over. A very good morning to all the dignitaries. I'm going to demonstrate the Hindi to Dogri machine translation system. It is a very simple to use tool. Like it is seen here, we have 2 text boxes. So on the upper text box, we place the source text, which is Hindi in this case. So I've already taken some news items, which I'll simply paste here and click on the translate button. And this Hindi news has been taken from BBC News, online BBC News. It says 25 साल की मगाली गिल नाम की एक महिला ने माराडोना के खिलाफ कोर्ट का रुख किया है और दावा किया है कि मैराडोना उनके पिता हो सकते हैं। इस मामले में कोर्ट ने कहा कि मैराडोना का DNA sample जमा किया जाना चाहिए. So it has been translated into Dogri as, now Hindi and Dogri both are written in Devanagari, and I'll just read the Dogri text. It says, पंजी बरें दी मगाली गिल ना दी एक जनानी ने माराडोना दे खिलाफ कोर्ट दा रुख कीता है ते दावा कीता है जे मैराडोना उनदे बाबू हो सकदे न. इस मामले च कोर्ट ने आख्या है जे मैराडोना the DNA sample जमा किया जाना चाहिए. So it is absolutely correct. So I picked up one more news article just to show that sometimes most of the times the system is 98% accurate, but little work has been done on lexical ambiguity. So whenever such words are encountered, there is the accuracy comes down to around 96%. So I've picked up this news, another news. And this is अक्सर लोग ठंड के दिनों में, okay, this is again an accurate one. Let me read this. I'll pick up another one then. अक्सर लोग ठंड के दिनों में तिल के सेवन की सलाह देते हैं क्योंकि तिल का सेवन सेहत के लिहाज से काफी फायदेमंद माना जाता है. ये स्वास्थ्यवर्धक गुणों से भरपूर है. ये आपके शरीर को अंदर से मजबूत कर कई बीमारियों को दूर करने में मदद करता है. तो आइए जानते हैं कि सर्दियों में तिल के सेवन से क्या-क्या फायदे हैं. So in Dogri, it's आम तौर ऊपर लोग ठंड दे दिनें च तिल दे सेवन दी सलाह दिंदे ने कि जे तिल दा सेवन सेहत दे इलाज शा बथेरा लाभदायक मन्नेआ जंदा है। एह् स्वास्थ्य वर्धक गुणें कन्नै पूरा है। एह् तुंदे शरीर गी अंदरा मजबूत कर केईं बमारियें गी दूर करने च मदद करदा है। आओ जानदे ने सर्दियों च तिल दे सेवन चा के फायदे मिलदे ने। So here I have noticed few mistakes which I like to share. So like here we have करने का लिहाज काफी फायदेमंद लाभदायक मन्ना जंदा है। ये now this word स्वास्थ्यवर्धक is a Hindi word. It has been passed as Swasthvardak. So that means it is missing in the dictionary. I'd like to state that the size of the dictionary is small. So if there is any Hindi word, it is passed into the Dogri text, though it is readable and understandable, but it is not a Dogri word. This is one mistake. And another one which I've noticed is Sardiyon. Sardiyon has also been passed as Sardiyon only. So these are the two mistakes that I have noticed here. Sir, if you suggest, I can translate a few more text. Otherwise, I would stop.
Yeah, please, Dr. Lehel, Neeraj sir, please let her know whether you want more sentences to be tested over here.
No, it's fine. Actually, since we do not know Dogri, so it will not be possible for us to exact. But I know it's a very good system. I have already seen it before, so I appreciate it. I just have a few questions from Preeti.
Yes, sir.
Is the system available online?
No, sir.
No, I think if you have done such a good work, you should definitely make it online.
No, sir, it is no. Yes, sir, I'm making the efforts to get it online. I've spoken to the university also, the Jammu University, if they could keep it on their server, but things didn't work out. I'm hopeful, sir, coming here by January, I'm going to place it somewhere.
Because this is a system which will be very useful for a common man, na? So just try to make it available online since it has such a good accuracy.
Right, sir. Right.
So people should definitely be using it.
Professor Lehel, may I request if we can make it online on our server in our university anywhere?
We can do it. We can surely do it. And on our center server, we can do it.
Even can it be integrated in Aggarwal, sir?
Yeah, we can do that also.
So Dr. Preeti, if you can think of, that will be a bigger opportunity for you if it can be integrated in the Aggarwal.
Thank you, sir. Thank you. I would love to do that. And by doing this, the system will be available for use. Thank you so much for providing this opportunity.
You have put in so much of effort, so ultimately people should be making use of this effort, na?
Yeah. Right, so, sir, right. Dr. Preeti, you can contact Professor Lehel regarding this, and you can make your system available for the fine.
Sure, sir. Thank you, sir.
Okay. Thank you, Dr. Preeti. It was wonderful.
Thank you, sir.
Demonstration. Thank you very much. So,
Thank you, Dr. Preeti. And Dr. Vishal, once it becomes available, can you please let us know? I would love to try it out.
Pardon, Neeraj sir?
Once it becomes available into Aggarwal, can you please let me know? I would love to try it out.
Oh, that's so nice. Thank you very much. Great. So definitely, sir. So can we start with the next one? Okay. So Jitesh, will you be able to present the next plagiarism detection tool for Indian languages with special focus on Hindi and Punjabi? It is by Dr. Rajeev Puri, Dr. Vishal Goyal, Jitesh Pubreja, and Jaswinder Singh.
Sir, I'm calling you. Just give me a minute. I'm having some difficulties.
Okay. Do you have the access to internet so you may be able to present it online?
I'm trying, sir. Let me call you, sir. Just a minute.
So, okay, I'll be presenting this on the behalf of my team. This is our Shodh Mapak, which is a plagiarism detection tool for Indian languages with special focus on Hindi and Punjabi. So it is a parallel system to Urkund, what we have seen for the UGC. So UGC has provided us with a parallel system corresponding to this for plagiarism detection. But what we have observed is that Urkund is not performing well for Indian language text. So we then requested the ministry to provide the funds for developing the system for the Indian languages as well. So to start with, we have started with Hindi and Punjabi. So this is the login screen from where we are logging into it. So this is the first screen after logging in. Here we have a lot of options with us in which you can see a lot of tabs are there. We have the home tab where we are presently looking at. Then we have the jobs tag. In jobs, it will be listing out all the jobs that we have already submitted and tested. In this, we can see we have a job ID that is the unique one, and we have the options of incorporating the language. So the user has to tell us whether you are submitting the Punjabi document or Hindi document or any other languages. So presently we have two options, Punjabi and Hindi. So if it is a Punjabi document, so it is displaying Punjabi. If it is a Hindi document, it will display Hindi. So user has to mention for getting the results in an accurate way. Then whatever the title of the file that you have submitted, it will be displayed over here, or whatever the title you have submitted. So it is displaying dates, are displaying two things. One is when you have submitted your document, when the processing has been finished on, and then the status is being shown that whether it is under processing or it is being finished. And finally, it will be showing you the results after the processing. So when we click on the this 3%, that is the result that has been given by our software. When we click on this 3%, so it will be displaying us the results, in which you can see over here that it is displaying same type of report that is being displayed by the Urkund, in which we have the summary part over here on the left hand side, where the title, document submitted, processed, submitted by, source, category, and number of consecutive words that comes under over here, and the result has been displayed. And here, what are the documents that has been searched for finding the plagiarism, and they have found there are the plagiarism for this. I'm not saying that which documents has been searched for. So what documents has come from where the matter has been, copied, or some matter has been picked up. So this is document that is the offline repository, and these are the sources. This is the internet resources from where the document has been, some document part has been found where it has been copied. So now when you click on each and every, like I click on this, so page by page, it will be displaying you the results along with from where it has been copied. So you can see over here page number 2, in which these page number 266, 6.85% matter has been picked, that is matching with the submitted document. So in this way, the whole document is analyzed and the result is displayed. From here, we have the option of download as well. So the report can be downloaded and they used for the purposes, and print can be done over here. Printing can be done. Then we have the administration, in which this is for our purposes, in which page controller, it is a dynamic website in which we can control the pages over here. We can manage the languages, we can manage the users, we can manage the OCR. So here we are using the Tesseract OCR, and we can manage the OCR over here. We can view the logs over here, we can commit the logs over here. Then similarity, so we have the independent modules as well. So if you want to just check the cosine similarity score, so you can put the raw text over here. You can choose the language, whether it is English, Hindi, Punjabi, and then we can choose core, means like English core you want to choose, Hindi, Punjabi. So that was the internal purpose, but we have independently module as well. So then the repository, when we talk about when we are generating the repository, so we have a crawler, we can upload the text, we can upload the PDF, we can list the repository. So whatever we have with us, it will be displayed over here as a list over here. So this is the list of Solr repository that we are using inside for our purposes. So these are the various tools that we have developed as an intermediate tools for using into it. First is the stammer, then text cleaner, then some modified text cleaner, Punjabi Unicode conversion, Hindi Unicode conversion, then stop word remover, final output, whatever, then ngram generator, keyword generation, PDF reader, OCR creator. So all the modules that we have developed as intermediate modules. So PDF reader, that was the very backbone, because whenever user is submitting any document in which Hindi or Punjabi text is there, so that PDF has to be read out. So when PDF has to be read out, the Urkund has the limitation that it is not able to extract the text out of the PDF file if there is Indian language text is there. So it basically it took 6 months to us to make this PDF reader module. Is OCR character means post corrections has to be done. So we have used tesseract. So some limitations were there that we have overcome it and we have gone ahead. So this is about our software. These are the contact details. These are the credits. The list of credits is a long list because number of persons has contributed to it into it. So this is all about, and this is the beauty of our system, that this will work for all the Indian languages when we are getting all the NLP resources. And it is my pleasure to inform you that this software has been copyrighted along with the Shodh Mapak. This image has been trademarked. So this is the achievements of our project. So thank you very much, and over to the session. Cheers for question answer session, please.
Thank you, Vishal. This is a very impressive presentation and very impressive work done. I just have a few queries. First thing is, what is the source with which you are comparing for this plagiarism?
We have taken a lot of resources like books from internet. Also, we have downloaded a number of text books, stories, and a PhD thesis is there. So first is from the Shodh Ganga. We have downloaded number of things from the Shodh Ganga, and along with that, we have gone to the Punjabi Sahitya Academy Ludhiana, where we have manually gone there, and we have downloaded, we have clicked the thesis pages along with the smartphones, and then we have converted into the text. And similarly, many physical books has been converted into the digitized form. And in Punjabi University also, we had gone to the library where number of theses are available that are placed on the shelves and that has not been digitized yet. So with very efforts, we have to make those theses into the digitized form. Still, it is not complete, but about 80% we have already done the digitization.
Oh, no, I can understand. There's a lot of work involved. So, are you? Any idea about the size of this database?
Jitesh, exact? Can you let me know about that?
Sir, it's on the repository itself. I think it's saying around 7,000 to 8,000 of Punjabi text and around 60 to 70,000 of Hindi thesis from Shodh Ganga.
Okay. That's interesting. And what is the algorithm which you use for comparing this?
The main backbone is, sir, the cosine similarity. But before that, we remove all the stop words and all the root words are converted to their original form. Okay. Then we perform the cosine similarity because it will be better to match after that only.
Okay. And is this also being used by some of the universities?
Sir, we have provided it to 3 universities for preliminary tests. And,
so what's the progress after that? Because this is very useful for all the universities. In fact, they should all be implementing this.
Yeah, in the start, they gave a positive review, and they also added a remark that the repository can be increased. But the limitation of the Punjabi resources available is the factor that...
No, sir, another problem is that already UGC is asking for the Urkund report.
Okay.
Because that is the forceful implementation by the UGC. So
Okay.
that's why the universities are not they are not very interested in taking these sources, because finally they have to go for the Urkund only, whatever the result
I
is.
think it's better that you approach UGC also, na? They should.
We have already approached, but no reply is there from their side.
So that's very unfortunate, because this is a very good tool which you have developed, but
Even I have written to InflibNet sir also, but they got annoyed about that why we are poking into their system.
okay,
They have the deals with the Urkund.
that's unfortunate, because you are doing a very good work, and actually they should be supplementing Urkund
Yeah.
also.
Sir,
They should,
moreover, this is Make in India product, and they have purchased Sweden-based product. So that is also one of the factor that they should consider.
okay. I think I may not be intruding in the time of others, because I always start asking the questions. So I'm sorry. So let other chairperson should also ask.
Yeah, no issues. Yeah, Neeraj sir.
Yeah, sir. I think this is very impressive, and I want to congratulate you. I really like how it starts to all the database and kind of pinpoint exactly the page where the the matches have been found. So I really like that specific. So you don't have to search through what specific page the copy might have happened from. And I think the copyright is really good. It will be very helpful. So I'm really looking forward to more reviews in future. I hope more and more universities can practice. And Punjabi is a great word.
आया भाभी ਦਾ ਫੋਨ ਕਹਿੰਦੇ ਵੈਂਟੀਲੇਟਰ ਤੇ ਪਾਤਾ
Yeah. So
ਚਲੋ
yeah.
ਮੈਂ
So
ਆਣਾ ਥੋੜੀ ਦੇਰ ਹਾਂ ਮੈਂ ਦੱਸਦਾ
Neeraj sir,
ਉਹ ਨਹਾਉਂਦੇ ਪਏ ਸੀਗੇ ਡੈਡੀ
Dr. Rajeev, Dr. Rajeev Puri is also along with us, who is the backbone of this project. So Dr. Rajeev Puri.
ਠੀਕ ਹੈ ਤੁਸੀਂ ਹਸਪੀਟਲ ਹੀ ਹੋ
Dr. Rajeev.
ਤੁਸੀਂ ਹਸਪੀਟਲ ਹੀ ਹੋ ਮੈਂ ਕਿਹਾ
Dr. Rajeev.
ਹਾਂ
Dr. Rajeev. So okay, so Jitesh, can you explain how solar works over here?
Okay. So sir, basically, it was a very big set of data that was not possible for a simple database to handle. So what we used is we leveraged the Solar repositories, and we created a module that will calculate the basic similarity score in a Solar, and then it will only give us the relevant documents. Then we can put our similarity system, and then extract the documents actual comparison report, whatever the document is comparing to.
Okay, thank you. So Dr. Rajeev, would you like to speak something about this software? You are also the part of this team.
Yes, sir. Actually, I joined late little. I'm sorry, I could not know what this Jitesh and others presented.
So we have given the demonstration. So anything you want to contribute on this?
Okay. Nothing special, sir. Actually, we have tried our best to evaluate this software on Hindi and Punjabi languages, and we would love to extend this to other languages as well. And,
okay. So okay,
the
thank you very much.
Is basically that this is language independent. We just only need to have a language cartridge attached to this, and it's going to work perfectly.
Thank you, Dr. Rajeev. So now we are moving to the next railway station announcement system for deaf by Rakesh Kumar. So Rakesh, please show your screen. Rakesh Kumar, please share your screen.
So just showing.
Okay. So after that, I request Praveen Prasannan to please be ready for sharing the screen for your system, a chatbot in Malayalam using hybrid approach.
Good morning all, this is Rakesh Kumar.
Rakesh, are you able to share your screen?
Yes, sir. I'm trying, sir. The network problem is here. Sometimes it's sign off.
Working as a system professor in Department of Computer Science. Good morning all. This is Jitesh Kumar.
Sir, I'm able to share.
Professor in Department of Computer Science, Dubey University College, Mirapur, Padha.
Okay, you played the video. Okay.
Yes.
2019, under the esteemed guidance of Dr. Vishal Goyal and Dr. Rajeev Goyal, Dr. Vishal Goyal is working as professor in Department of Computer Science at Punjabi University, Padha. To his credit, he has responded to element particularly favorite personal. There are also some other better learning practices. Dr. Rajeev Goyal is working as associate professor at Department of Computer Science in DAV College, Jalandhar. With his guidance, I started making a software for deaf people for producing the announcement in Indian Sign Language animation. So let us start with the portal of announcement system for railway stations in Indian Sign Language. When we click on the railway link, in this submodule, there are two sections. On the left hand side, there is the announcement section where we can input the announcement or enter the announcement. On the right hand side, there is computer generated avatar which will display this announcement in Indian Sign Language. So we have divided the announcement into two categories, static announcement and dynamic announcement. Static announcement are those announcements which are complete as a whole. There is no changing part in the announcement. So we have selected more than static announcements which are used at the railway station. So this is the list of all the announcements that are used at the railway station. So like we can choose one of the announcements and we can see what the computer generated avatar will do. So we choose don't enter while train in motion. So when I select this announcement and play the static play, so the computer generated avatar has played that animation in Indian Sign Language. So let us choose one more static announcement like smoking is strictly from the state. So when I select this announcement and play on the static play button, so on the right hand side, the computer generated avatar has played that announcement in Indian Sign Language animation. So another category is the dynamic announcement. Dynamic announcement are those announcements which have some changing parts. So we have divided these announcements into further subcategories. There are around 10 subcategories: arriving, arriving shortly, available, departure, departure shortly, ready to arrive, late, empty train, special train, and train. Let us start like there are other three parameters we have to choose. That is the number. So I have chosen two numbers and the time in hours, 2 hours. Okay, and here is the minutes. I have to choose 10 minutes. So when I enter these parameters and play on the dynamic play, on the right hand side, it is has shown the train will arrive in these at this reference number and the selected after the selected time. Let us choose another one, more announcement. It is like available. Or we can choose the running late. So I choose the running late and then choose the platform number. I choose the platform and the time. Into the animation. I just want to add one thing while playing this demonstration. While developing the announcement system for the railway system, the biggest challenge was to collect announcements which are used at railway station. A lot of time was consumed for collecting these announcements. The another feature of this announcement system is that these announcements are played by the computer animated character, which is not a real human being. It is a computer generated avatar which will play the animation. So this avatar can be of different look. Like we can see in the right hand side, there are the different looks are available. Like we choose the first one is Luna, second one is Ziggy, third one is Anna. Let's choose Anna. And the avatar will be of the Anna character. So these are 5 looks. We can choose any of them, and the avatar will not create an animation on those looks. I just want to add one more thing, that I am working to enhance this system for the other public places like airports and bus stops, and I will try to develop the new system for them. And this is the demonstration of my system. So thank you for your watching my demonstration.
Any queries, please? Dr. Asif has also joined. I welcome Dr. Asif. Welcome this another session here, Mr. Sanjeev Gupta. I welcome you, sir. May I request the session chairs? Any queries are there for Rakesh?
It's fine from my part.
So okay, so we are moving ahead with the next demonstration. I need to check whether Mr. Parveen Prasannan is there. No, so presently he is not there, so I will check, I will call there. So next again, I request Rakesh to present the airport announcement system for deaf.
Hello. Hello.
Yes, Rakesh.
Sir, I have some bandwidth issues.
While just explain it. You can just explain it.
Okay. So just I want to share the screen. So this is the another module which is displayed on the screen. That's it is a airport. We have made this. So in again this module there are two sections. In the left hand side there is a announcement section where we can enter the announcements as a static as dynamic announcement as well. So in the right hand section, a computer generated avatar will play the Indian Sign Language animations of these announcements. So we have divided the announcements into two categories, that is static announcement and a dynamic announcement. So in the airport system, we have collected more than 256 at the airport. So these are the airport announcements, static announcement. These are the announcements, they don't need any changing part. So like we can check these announcements. So first one, I try enjoy your flight. So when I select this announcement and play on the static play, on the right hand side, the computer generated avatar is playing these announcement into Indian Sign Language animations. So let us try once more. I collect your check-in baggage. So when I again play on the static play, so this statement is also announcement is also playing in the Indian Sign Language animation by the avatar. So in the same way, we are having dynamic announcements. So dynamic announcements we have categorized into around 11 subcategories. These are the pre-flight, pre-boarding, in-flight, gate change, refreshment, paging, delay, security, post-flight announcement. So when we select any one of statement and check what is it do. So I select pre-flight category and select the first statement, ladies and gentlemen, welcome on board. So when I select this announcement, so these announcement also require 3 other dynamic part, that is the source, like I input New Delhi here, and destination parts, so Amritsar. So it also require the flight number. So I enter the flight number. So when I play on the dynamic play, so it will now play this announcement in Indian Sign Language animation. So let us try one more statement, like we can choose a gate change. So when I select this category and choose a gate change announcement, the flight will now depart from the gate number. So when I just need one variable here, so I just have to enter the gate number. I have to add it 12. So the flight will now depart from gate number. So now the variable gate number is to get replaced with this input. So when I play on the dynamic play, and this is now playing as Indian Sign Language animation. So these are the some categories of announcements we have collected, and we have tried to make our best, try to our best that incorporate these announcements into the Indian Sign Language animations. So it is again the biggest challenge to collect these announcements, as these announcements are not easy available. So we have tried so many sources to collect these announcements. So another feature of again this system is that the this animations are not played by any human video or like a real human being. It is a computer generated avatar which will play these animations. So I'm also working on the enhancing this system to other public places also, like bus stands and railways. So this is my demonstration of my work, and thank you for your watching. If any query, please go.
Yeah. So any queries, please, from the session chairs? This is for your information regarding this software, that we are going to extend this software for other Indian languages. We have made a consortium at our own level. There is no funding on that, but we are going to add announcement in all the other languages as well, because the sign language will remain the same, but only the display of the language will be different. So we are going to extend it, and in near future we'll be incorporating that as well. So over to the session chairs for the query sessions.
Yeah. Hi, this is Neeraj. I feel this is really good, and I feel maybe this can be like for future integrated with the flight system. Like there are fixed set of flights which goes at fixed times, and they have fixed gates most of the time unless the gates change. So rather than by inputting all that information, if there are like the links display at what point, like if right now what flights are leaving from what intervals and what times, then we can just click on it and then see and then get the sign language.
So that will be better. So we will incorporate, sir.
But this is really good. Thank you.
Thank you, Neil sir. Yeah, so Sanjeev sir. Yes, sir, please.
May I ask, or somebody else?
No, sir, please. Yeah.
Okay, no, I thought somebody else was going to start. This is no doubt a very good work, and a very first time I think very innovative also. First time I think it is being done for any Indian language also. I just have one simple question, that for example, how do you convert the name of the cities if supposing it is Delhi, or say a new city which is actually not seen before? So how does it convert it in the sign language?
It's a finger spelling, sir.
No, spellings will be then in English or
It
in
will be English only, because there are no signs on Indian languages. Even for Punjabi, there is no ISL. So whenever they have to explain Uda, so they are explaining with the like picture. They display the picture of camel, and they explain that this is camel. So there is no sign for Uda. So there is all signs for A to Z, but there are no signs for Indian language alphabets.
But sir, we have added some cities of the India into our system. So when the city name comes, the city name will be pronounced exactly into the Indian Sign Language. So we have tried some cities to integrate with our database.
No, but the city names are you just spell them out, or there are some specific signs also for the cities.
Some cities have some specific name, and which cities are new, that will be finger spelled.
Okay. So then, how is it then different from the English Sign Language, whatever is being shown over here?
Okay, so the English Sign Language is they have so many versions in there. Like American Sign Language is different, and British Sign Language is different. So they have only in India the British Sign Language is similar like Indian Sign Language. So there is no regional sign language, so only Indian Sign Language, and in Indian Sign Language behind only English is used.
Oh, no, so for example, if I just have this announcement that this flight will go from Delhi to Amritsar at this time, okay. So is the sign language same in British English as well as in Indian Sign Language, or there is any difference?
There will be some difference. Like the Indian sign language is not universal. It varies from the region to region.
No, that's what I asked now. British English Sign Language and Indian Sign Language. If I have to make this announcement that this flight will go from Delhi to Amritsar at 11 a.m. So what is the difference between the signs being displayed in both the cases?
Sir, basically, our Indian English has been derived from the British English. So they have the similar sentences or signs are used. But there is a difference. Like you can say in India, we have other dialects. So there is a difference in the.
You're not getting my question. I'm just asking for this specific sentence which I just said.
They have, sir, if you talk about different sign languages, if you talk about Indian Sign Language, so a number of hands to be used for making the signs, for making the gestures.
So no, just in this example that this flight will go from Delhi to Amritsar at 11 a.m.
Yeah.
So what is the difference in the signs being displayed by both the sign languages?
Sir,
may I? Yeah. Please, Dr. Malik.
Sir, actually, first of all, the grammar rules are different for Indian Sign Language and the British Sign Language. The grammar is totally different, just like subject, object, verb, and subject, object, and verb, like that. And second difference is that the signs are totally different for American Sign Language and Indian Sign Language. Just like
British Sign Language. And in fact, the subject object should not make one difference when you talk of signs.
Yes,
sign language, that should not make any difference. That will be only written form, na?
Yes, you are right, sir. You are right. Just like the signs are totally different. Just like if you talk about thank you sign, some people
same sentence which I just asked. Can you just, because that's only from my I'm curious to know what is the difference between those. So in that simple sentence, how are those signs will be different in both the languages, British Sign Language and say Indian Sign Language?
Sir, for that, if you give me some time, so I will download the signs that they play for this sentence. I will make a sentence and I will send you.
No problem.
Because I do not know how they sign these words in British Sign Language or American Sign Language.
Okay, fine. Thank you.
So any other queries?
Not a query, but as per Mr. Lal, while the question is still valid, I was just thinking, should we even worry about Delhi to Bangalore, or should we look at the flight number? because there may be 2 flights going from Delhi to Bangalore at the same time. What is important is the flight number. So should we focus more on that in this case? Absolutely, the question remains valid from the sign language perspective, whatever Mr. Lal asked. Just a passing comment, not to. Other than that, I don't have any question.
So thank you very much. So should we move ahead with the next demonstration? Then we have machine translation system for English to Indian Sign Language using synthetic animations. So Dipali will be presenting that. So Dipali, please share your screen. Rakesh, you can stop sharing the screen, please.
Okay, sir. Thank you.
Dipali, I hope you are there. No, Dipali is not there. So Mr. Praveen has joined us from IC Force. So I request Mr. Praveen to please present his demonstration on a chatbot in Malayalam using hybrid approach. Mr. Praveen Prasannan.
Hello, sir.
Yeah, good morning, Praveen. Please share your screen and present your demonstration.
Yeah. So can you see my desktop now?
Yeah, please start. Your screen is visible.
Yeah. Actually, chatbot is a conversational agent that can converse with humans. There are mainly 2 types of chatbots. One is rule-based and another is AI-based, that is artificial intelligence-based chatbot. So both the chatbots have their advantages and disadvantages. The advantage of a rule-based chatbot is that it will give always correct reply for the given query, which is already in the database. And it's one of the drawback is when a question is asked outside the knowledge base, then it will fail to produce the relevant reply. And in the case of AI, it can produce reply from scratches using NLP techniques. But the issue is it needs a huge amount of data for training. In some cases, it will not be available. So using the concepts of both the both the rule-based and AI-based chatbot, we developed a hybrid chatbot in Malayalam. Malayalam is a Dravidian language spoken in the southern state of India, Kerala. And we used hybrid technology for developing this chatbot. And this is the product that you are seeing now. First, it asks the name of... Hello, sir.
Hello, sir. Hello.
Sir? It's okay, please continue, please.
Okay. Here, the bot is first asking the name of the user. That means enter your name. I am typing my name here. And it's asking Namaskaram, and it's saying Namaskaram, that is, it is greeting me. And it's asking, am I isolated? That this chatbot was developed during the Corona pandemic for assisting the state government of Kerala. The main issue during this period was the misinformation and malinformation that were prevailing during this time period. So the government of Kerala needed a single source of truth that are authenticated by them. And we associated with them to develop this chatbot. And this chatbot is for giving the FAQs and government orders regarding Corona in Kerala. And the bot is now greeting the user and is asking whether he is isolated or not. And we have created 3 cases here. That is, the user is isolated and the user is not isolated. And I'm saying the user is not isolated. Then he can go to the chat directly. And if a user, if he is isolated, I'm to show it once again. This is the second case. And a name. and he chooses isolated, then the bot asks whether he is registered in the official government website. And if he has registered in this website, he can again go to the chat directly. And if he has not registered in that, the bot will give the link to register in that website, and clicking this website, this is the portal developed by the Kerala government, and he can register here and continue to go with the chat from here. And if I am asking any query, there will be drop downs, and the user can select if any of the drop down matches with his query. And I am choosing one, and it is I am asking any Vayama Varanada Corona Mulamano. That is, I am feeling sick. Is it due to Corona? And the bot is saying not all diseases are due to Corona. And we included all the helpline of all the districts of Kerala, and selecting any one of the helpline, it will give the corresponding details. This is almost like a rule-based chatbot. That is the exact query we are giving, and we are getting the reply. So if an user asks a query, which is not in the database, so that's why the drop down is not showing, and he is giving the query. Even in this case, it is providing us the queries, whether it is matching with ours. Actually, I asked any mask dharikano. So the keyword here, it is mask. After removing all the stop words, the keyword is extracted, and they are showing the queries regarding with that keyword mask. On selecting this, I can see various means the details of that query, and he can get it. So coming to the technology I have used for this hybrid approach, the user query is first tokenized, then it is stop word removed, and root word extraction is done, and a similarity measurement is performed on that keyword. The purpose of tokenization is to get the sentence into tokens for further processing and understanding. For English, there is a package in Python called NLTK, which helps in tokenization. But for Malayalam, it was not fully compatible. So we use space delimiter for tokenization. Then we went for stop word removal. Stop words are those words that do not add much meaning to a sentence. In English, there is a readily available stop word list, but in our case, we need to develop our own stop word list. But it was a tedious process because Malayalam is a free word order language. So the user can ask query like as he wish. So developing a stop word list in Malayalam was a tedious process. After removing these stop words, root word extraction was done. Root word extraction reduces the inflected form of the words to its base or dictionary form. Suppose the keyword we obtained was for in English, if the keyword was like playing, after root word extraction, it will give play. That is its root form. So in Malayalam, there was no readily available package, and we developed a package for this purpose, and we made it publicly available. So if we get the keyword, then its root form is taken. Then the similarity of the keyword obtained from the user query to that of our data set is done using a similarity method called Jaccard similarity. Jaccard similarity measures the similarity and diversity between two sets. It is defined as the ratio of intersection to union of two sets, and there was no readily available function for Jaccard similarity for Malayalam language. But we used the concept of Jaccard similarity to develop our own similarity measurement in Malayalam. And we made 3 cases for our system. The first case is exact similar keyword. That is, if the exact similar keyword is obtained, then the schemes related to that keyword will be fetched, and this will be bot's reply. And the second case is almost similar keyword. If a keyword, the exact similar keyword is not found, then almost similar keyword in the database is obtained. Then the schemes related to that keyword will be fetched. And the third case is not at all similar case. If the similarity measurement is below 50%, then the bot says, Bhayam venda jagrita madi. That means don't be afraid, be conscious about coronavirus. And this is the main technology behind our chatbot. This is our hybrid technology. Thank you, sir.
Yes, over to the session chairs, please. Yeah, Professor Gurpreet Singh Lehel.
Okay, thank you. So it's a good, nice and interesting work. What is the size of the database, training database?
My size is around 250, sir.
250?
Yeah.
No, 250, what's the unit? 250.
What's that? Sir, pardon, can you repeat it?
What is the size of the training database?
So actually, we didn't have any readily available data set. So we created our own database with the help of the Directorate of Health Service Kerala, and in total we made a 25,000 of data set.
Okay, so this means this is mainly focused on this medical. It is related to medical chat only, I think, mainly, na?
So this technology can be extended to any other domain.
No, that I know, but your present works looks to be more focused over there.
Yes, the scenario for creating this chatbot was during the
I can understand in this Corona time, so it will be quite useful. That's good. Okay, and then you were talking that getting the stopwords is a challenge. How many stopwords did you got finally? What is the count of those?
Around 300 we created, sir.
So then how do you identify those 300?
So actually in Malayalam, the slangs are different in each region.
Okay.
Because if we ask what in English, for that what we have endu, enda, enduta, that inflected forms are many.
Okay.
So we made a huge, we need to collect all those stop words.
No, but usually can't you look for the stop words based on the frequency? Usually they are the most frequently occurring only.
Yes, sir. But the thing is, the people may frame his own sentence because Malayalam is a free word order. So he can ask a question in different ways. The same question can be asked in different ways. So the stop words will be different in different cases.
No, how do you define stop word? So what do you call
the most frequently used terms like WH questions? Then
that's what I'm saying. Then you can just sort the database on the frequency wise. Then you can easily extract them. Na?
So can you repeat it once more?
These are the most frequently occurring terms, which you yourself also said. So that's what I'm wondering now, that why it's such a big challenge, because from the database you can just actually sort it, take out the unique terms and sort them, and then I think you can easily get the most frequently occurring terms over there.
So the thing is that I already mentioned is that in Malayalam, the people will ask for a single word in English, like what. For that word, Malayalam has got many many terms, like endu, enda, enduta, endina. These all are 4 words will match only one English word, that is what.
Okay.
So in different regions, it will be different.
Okay, then fine. Thank you.
Okay. Yeah, Mr. Sanjeev, any queries, please?
How have you thought about the extension to other languages in other Indian languages like Kannada, Tamil? Has it been thought through?
Sir, can you repeat the question?
How much effort that would be?
Sir, pardon, can you ask once more?
Sir,
sure.
Your voice is
if you extend that to, is it?
So I'm getting.
Is it any better?
Praveen, sir is asking that how can you extend this software to other languages?
Yes, sir. Actually, we tried to build a multilingual chatbot, but with that time constraint, we couldn't. And we also made an English chatbot using the same technology. So we understood that this technology can be extended to other languages also. Hello, sir.
Your architecture allows to extend it to the other languages as well.
Yeah, the data sets, we have a specific data structure format, sir. If that we put the data into that, the language is not an issue.
Okay, that's great. Mr. Neeraj, any queries, please? Okay, so thank you very much, Praveen. It was wonderful product you have developed, and congratulations to the ICFO's team. So next we move to the next demonstration on machine translation system for English to Indian Sign Language using synthetic animations. So
Thank
can you
sir.
stop sharing, please, Praveen?
Yeah, thank you, sir, for choosing our product. Thank you, sir.
Yeah, congratulations. So Dipali, are you there, or Dr. Lalit Goyal, will you be presenting? Yeah.
Hello.
So, yeah, Dipali, please present your presentation, please.
Yes, sir. May I share the screen, sir?
Yeah, sure. So the topic of the product is machine translation system for English to Indian Sign Language using synthetic animations. So the contributors are Dr. Lalit Goyal, Dipali, Amandeep Kaur, Gurdeep Kaur, and Dr. Vishal Goyal.
Hello. Hello. हेलो
दीपाली प्लीज आप इंग्लिश टू आईएसएल वाले टैब को चूज करो, आपने दूसरा टैब चूज किया हुआ है।
हाँ जी सर।
एक मिनट होल्ड करना मैम। हाँ जी, नाउ यू कैन स्टार्ट योर डेमोन्स्ट्रेशन।
यस सर। गुड मॉर्निंग टू ऑल ऑफ यू। Myself Dipali, PhD research scholar under Dr. Vishal Goyal, and my co-supervisor Dr. Lalit Goyal. The topic of our presentation of our demonstration is automatic translation of complex English sentences to Indian Sign Language synthetic video animations. This is an overview of our tool. Here we can put a input text of any English sentence. That is, now first we will put the complex English sentence, that is sorry sir, the server is taking a lot of time to show the output. It's out. Hello. Hello.
Hanji Dipali, continue its work.
Hanji. Okay, sir. The output here is in Indian Sign Language. I coffee too cold. I eat microwave heated. Sir, due to some network issues, I think the avatar is unable to do its signs.
Hanji Dipali, please explain your system. So, okay, I will explain the system. I think she is facing some issues in that in internet connection. So this in this system, this is English text to Indian Sign Language for deaf people. In this system, what we are doing is we are translating the English text, including simple sentences, complex sentences, and compound sentences. So all three type of sentences are converted into the Indian Sign Language automatically. And the basic challenges what we have faced over here is we were not able to find the person who can guide us about the grammar of conversion. So with very hardships, we have found the rules for the conversion of English to Indian Sign Language. That was the first step. Then we do not have the animations for the words for all the in ISL. So we need to hire one Indian Sign Language interpreter for that. So once we have done, we have converted into the animated videos. And corresponding to that, we need to write the SIGML codes. And that was also challenging because writing SIGML code for each human video, that was a big challenge. So it took approximately, Dr. Lalit, can you just come with me that it took 8 years to develop this system. So Dr. Lalit Goyal started this system developing for the simple sentences. And then within 8 years, we have converted into simple, complex, and compound. So this is all about our system. Dr. Lalit, would you like to contribute anything, please?
Yes, sir. It was actually the very hard part that we could not generate the animations of the signs. It was very hard part in that. And second hard part that Dr. Vishal has contributed that there was no person guiding us how to implement the grammar of English into the Indian Sign Language, because in Indian Sign Language the grammar is not properly standardized. There are no specific rules how they sign these sentences, but still with the help of IR Indian Sign Language Research Institute that has been developed in 2000, that have been into working in 2017, I think. That the government has taken initiative to standardize the sign language of India. We have also taken help from that institute. We have taken help from the Coimbatore Institute, where the signs were developed in human videos. We have taken the help of that video, but still there was a lot of difference of signs in the South Indian Sign Language Dictionary and the dictionary that has been provided to us by the Indian Sign Language Research Institute, New Delhi. And now we are in the form of that we are standardizing the signs as well as we are standardizing the grammar rules of this system. And this system has been the first Indian working system, and no system has been available in India till now that is working. So a lot of help is required from the institute, Indian Sign Language Research Institute. Too much help is required so that we can make this system working for the public, so that it can be useful for the hearing impaired people.
Hello. Yes, I welcome Dr. Rajeev RR from IC Force. I welcome you, sir. I welcome Professor Sanjay Dwivedi ji from Central University of Lucknow as session chairs. So over to the session chair for the question answering session, please. Okay, so Dr. Lalit Goyal is sharing the screen and showing the demonstration.
Sir, may I have some sentences that?
Yeah, sure.
So I have a sentence, I need to go home, but all the flights are cancelled. So here, okay. So when I submit this sentence, so this is a compound sentence, and this compound sentence is first converted into the simple sentence, and then it can be animated. I home need go, but all flights cancelled. So the words that are not available in the dictionary, those are finger spelled, right? And we have made this architecture so that all the compound and complex sentences are converted into the simple sentences, and those simple sentences are then converted into the ISL sentence, and that ISL sentence is played by this avatar. So I may have tea and he likes coffee. This is also a compound sentence. It will be first converted into the simple sentences, and then it will be converted into the ISL sentences as per the grammar rules. I like tea, he coffee like. He coffee like. This is the actually by using grammar rules, this is the ISL sentence. And here on the right hand side, this avatar plays these words of Indian Sign Language sentence. So any question? So any question or any suggestion, please, you may ask.
Okay, Lalit, I know you, Dr. Vishal, and your team have been doing a lot of pioneering work in this field. So congratulations for that. I just have a few doubts. First thing is, you're saying you're converting English to ISL. So I was wondering, why can't you just convert English to one of the Indian language, and then because otherwise you have developed the system now which say displays the Indian text in Indian Sign Language, for example, Hindi or Punjabi. So can't you just go the other way, that given in text in English first convert into Hindi or Punjabi and then
Sir, actually, in Indian Sign Language, all actually signs are in English, and these deaf people are taught English sentences, and those English sentences are actually signed. So for Hindi and Punjabi, we do not have any sign language in actual.
Then the other way around is, for example, I have text in say Hindi or Punjabi.
Yes, sir.
Then how do you go about it?
Sir, that will be first converted into the Indian sign sentence, Indian Sign Language sentence, because so there is a difference between any spoken language and sign language. The difference is that in the sign language, only the important words are signed. Rest of the words which are not signed are eliminated. Okay. For example, here, I like tea, he likes coffee. So here, and has been eliminated because and is not signed in Indian Sign Language. So that is why. So if there is Punjabi sentence, then we can convert it into the signed sentence by eliminating all the words which are not signed, first of all. Second of all the inflections of the words are not signed. Only the first form of the verb, you can say, is signed. All the other inflections are not signed. So inflections are removed from the words.
No, so I was just wondering if the same sentence, I like tea and he likes coffee. So
Yes.
that means instead of that, I have मुझे चाय पसंद है और उसे कॉफी पसंद है.
Yes.
How will you go about displaying this?
मुझे चाय पसंद है, मुझे चाय पसंद है, ये हो जाएगा सर. और उसमें हट जाएगा.
No, so then
क्योंकि सर पंजाबी और इंग्लिश सेंटेंस में क्या फर्क है, सब्जेक्ट ऑब्जेक्ट वर्ब का जो अरेंजमेंट है दैट इज डिफरेंट. सो पंजाबी और साइन लैंग्वेज का अरेंजमेंट सेम होता है, पंजाबी और हिंदी सेंटेंस का और उधर साइन लैंग्वेज का.
मुझे चाय पसंद है एंड उसे कॉफी पसंद है. These will be the two sentences.
Yes. और हट जाएगा उसमें से सर.
And you will be okay making two sentences over there. Okay. ठीक है. Actually you are doing pioneering work, and whatever you'll be doing, actually the others will be following. So this is very good initiative your team has taken. My best wishes that you succeed further in this field, and actually you are doing a great social service. Thank you.
Yeah, thank you sir. आपकी blessings हमें बहुत ज़्यादा चाहिए actually. हमें प्रॉब्लम ये होती है सर कि हमें कोई भी अभी तक ग्रांट भी नहीं मिली है कोई सिस्टम को डेवलप करने के लिए, और ना ही हेल्प करने के लिए हम ISLRTC इंस्टीट्यूट कई बार गए हैं, लेकिन वहां से इतनी ज्यादा हेल्प नहीं मिल पाती है. हेल्प मतलब हमें फोर्सफुली लेनी पड़ रही है. दे आर नॉट विलिंग टू हेल्प. डोंट नो व्हाई.
Otherwise we have so many ministries, so many departments which are especially for these for actually supporting them, and we have also ministry also, but I'm surprised that they are not providing you this help, and this is a very basic resource which is actually needed.
Yes sir.
Okay, all the best from my side.
Thank you sir. And Dr. Lalit Goyal is really backbone of our project. Thank you Dr. Lalit.
Thank you.
Thank you sir.
Dr. Sanjay Dwivedi ji, any queries please from your side? Dr. Lalit, can you stop sharing please screen?
Yes sir.
Dr. Rajeev, any queries from your side? Mr. Sanjeev, any queries?
No, Mr. Vishal, we are good, but yeah, definitely pioneer work in this area. Maybe I will talk to Lalit offline to see what can be done there.
I think you both are the classmates, right?
Yes, I'm proud to say
that's
that.
Nice.
Yeah, 2000 batch.
Oh, great. Okay, thank you very much, Dr. Lalit. So now we are moving to the next. Mr. Mukhtar, are you there? Yes, Dr. Mukhtar. Mr. Mukhtar is there. No doubt he's going to be Dr. Mukhtar in coming days. So Mukhtar, you will be presenting your system on sentiment analysis of English Punjabi code mixed social media content. Please share your screen, Mukhtar. Mukhtar. Hope I am audible, Mukhtar. Please share your screen to present your demo. Mukhtar, please share your screen.
Finally, I've decided to retire. What do you mean by that? I will not be making money in my life? No. I will be earning, but I will not be trading my time for money. This is exactly we do in job or business. In last 22 years of my
Good afternoon, all of you. My name is Mukhtar Singh, and I PhD under the supervisor Dr. Vishal Goyal and co-supervisor Dr. Sahil Raj. My topic name is Sentiment Analysis of English Punjabi Code Mixed Social Media Content. As we type the Punjabi Code Mixed Social Media Content, as we know that in India there are 22 official languages and many more regional languages. There has a little work has been done in Punjabi language, but not work in later to English and Punjabi code mixed text. So today I am presenting the demonstrate about on my tool name is Sentiment Analysis tool. So in this tool we can enter the input like Punjabi, English and mixed, even romanized Punjabi text. So in this tool, first of all, I type the one sentence like farmers will move lately against to center. So I write the one sentence. So in analyze, we can check it sentence is either positive, negative, or neutral. So according this sentence, this is overall negativity. So result is also negative. So this is the correct output. And in this up to 5 gram n gram approach is applied. Firstly, we checked the approach up to trigram. So I want to show you. Name sentence up to trigram. So there are also negative. So we applied firstly up to trigram approach, then checked up to 5 gram approach, then we present the similarity up to try and 5 gram. So we applied the n-gram approach up to 5 gram approach. So I want to show the one. I already opened the Facebook page. There are lots of sentence in randomly. I want to show you one sentence. Suppose this sentence overall represent the positive sentence. So let's check. So this sentence in tooltip show the number of bigram is the positive sentence. So overall positive percentage 0.8. So this tool will help where user type the code mixing languages on the platforms such as Facebook, Twitter and YouTube. This tool will be very helpful to check the sentence whether it is the positive, negative or neutral. So this is the good tool. So thank you very much all of you. Thank you so much.
Mukhtar, now am I audible to you? Yeah, Mukhtar.
Hello. Hello.
Yes, yes, Mukhtar. So who is
Are you
sharing
listening,
the
sir?
screen, please? Someone is sharing the screen. Who is sharing the screen?
Okay, okay.
Mukhtar, are you sharing the screen?
Yes, sir.
Please stop sharing the screen. Please stop sharing the screen.
Okay, okay. Yes, sir. I stop the share screen. Hello.
Yeah. So, Mukhtar, am I audible to you? Mukhtar, unmute yourself.
Okay.
Okay.
Sir.
Yeah. So over to the chairpersons, please. Dr. Lehel, Dr. Rajeev, Dr. Sanjay, Mr. Sanjeev. Any queries, please?
Okay, nice work. I just have a few queries. Since the Mukhtar, you are saying that this is a code mixed sentiment analysis. So
Yes,
supposing
sir.
I just write farmer bilde khilafan in Roman.
GG.
So,
Yes, sir.
so then what will be the output over there?
Then they will produce overall the negativity because khilaf is the negative word.
So, but I have written khilaf in Roman in Roman Punjabi.
Yes, sir. Even they will write English against and write in Punjabi khilaf.
Against was in English, na? So can you just show me that
yes,
demo?
Sir.
Mukhtar, share your screen and try this sentence with your system.
Yes, sir. Yes, sir. In Romanized.
Khilaf han. Farmer bills no.
Sir, it is depend on the corpora because according to reason some person write the KHILAF. So this is the overall lecture.
That's good. Just one last question. Just one last example. So now you say farmer bilde hak vich nahi han. Farmer bills de hak vich kisan nahi han.
Right, sir?
Yeah.
Yes, sir.
Okay, so nahi han it has taken us. That's good.
Yes, sir.
Okay, then just one last question. This is regarding the size of the 5 grams. Actually, 5 gram really takes a lot of space. So what is the size of the 5 grams you stored?
Yes, sir. Sir, firstly, I collected the unigram sentences in distribute as
No, just
positive,
size.
negative, and neutral. In 5 gram, there is 46,481.
Okay, so then that's not very large as I was thinking of. Okay.
No. Sorry, sir. I distribute distribute is as a positive, negative, neutral, and unsorted word. In positive, there as 7 lakh 64 uh, 7,64,681 is the positive words.
Yeah,
And
that
81.
that looks more reasonable.
Yes.
ठीक है,
8
fine.
lakh
Good luck.
11,541.
I got it.
I want to, sir, show you the static. So firstly, I collected the total number of 10 lakhs instances from different domains such as agriculture, religion, politics, entertainment, educated, and total number of 10 domains, sir. After that, I remove the duplicacy sentences and then collaborate the unique identification as the norm word. Then there as unigram, there has 377078 is the total number of unique word. After that, we applied the bigram, trigram up to 5-gram approach. Then they have collaborated the number of sentences according to n-gram approach, sir.
ठीक है. This is fine. That's good work.
Thank you, sir.
Thank you
very much, sir.
Thank you.
Please. Any more queries from other session?
So, Mukhtar, if we take sorry, Vishal, am I audible?
Yeah.
Yes, sir. Yes, sir.
It's echoing, but it's audible.
Yeah, this seems to be a problem. But let me ask you a question. Mukhtar, if I make it a complex word or a complex sentence with affection in the first and negation in the negative, can you play that for me?
You means ambiguity, sir.
Yes. Like for example, किसान गवर्नमेंट को चाहते ने but is bill के खिलाफ.
Okay. I already mentioned the example if you seen in the sentence. Like this phone is good, but backup बहुत घट है इसका.
Right.
First is the positivity, then second move to the negativity. So they will produce overall the neutral word because 50% is the positivity and 50% is the negativity. So positive negative is the same as the neutral sentence they will produce.
But what if we get the similar sentence from the 10,000 views or 10,000 such comments there? You have to bring some aspect of negativity of the backup, right?
Yes.
So how do you do that?
They will, sir, actually overall work is on the sentence based, not is the paragraph based. So they will check and produce the output according to sentence by sentence. If there are 10,000 sentences, they will result 10,000.
So there is no further formulation of this work to find the real sentiment.
Actually, they will, if you will add, insert the in this input box, suppose you will enter the 10,000 sentences, then they will collaborate the unique sentences, and after that they will produce the only one output. It may be positive, negative, or neutral.
Okay, fair enough.
Basically, I think it will give you average of all the sentences. Am I right, Mukhtar?
Yes, sir. Firstly, count the total number of positive word. First, up to 5-gram. If suppose they will met the one positive word in 5-gram, then their priority will be 5 because in met the 5-gram database. After that, they will one sentence met the negative word in 4-gram. So 5 is higher than 4-gram approach because 5 is the positive word, 4 is the negative word. So they will produce the output positive, not negative. So after that, they counting the total number of positive and total number of negative. If more than positive word as compared to negative, then they will positive, and vice versa. And if they will number of positive and negative same, then they will produce the neutral result. I am right?
Got it. Any more questions from other session chairs, please? Okay, Mukhtar. It's a wonderful work. Thank you very much. Best wishes. Okay, next we call upon Nitika for her presentation demonstration on language identification and normalization of code mixed English and Punjabi text. Yeah, Nitika. Mukhtar, you stop sharing your screen.
Yes, yes, sir. Okay, thank you.
Good morning, all. I hope I am audible, sir.
Nitika, continue, please.
Okay. Okay, I am here to give the demonstration for my tool, language identification and normalization of code mixed English and Punjabi text. So I have completed this software under the supervision of Dr. Vishal Goyal and Dr. Singh. Coming to the software. Am I audible, sir?
Yeah, please come near to your mic as well, otherwise audible.
Recently, me and Mukhtar both have contributed in this tool. I have performed the task of language identification, normalization, and transliteration part. A few days back, I have tried to merge these two components. Coming to first to the language identification part, it will perform language
Nitika, share your screen. Your screen is not visible.
Okay, sir. Visible, sir?
Yes, now visible.
Okay. Coming to the first module, language identification module. Here, the language identification has been done at word level. I have given some prescribed input. So it will pick up every word. It will be chosen as if it is English, Punjabi, or some universal tag. Second portion is of this Mukhtar's work. It will perform sentiment analysis. Here we can see some of the results. For example, ki hal hai, just asking how are you? It's being neutral. Next, coming to the normalization module, it will, for example, be lots of acronyms, etc. are being used nowadays. These are normalized to their standard form. In Punjabi, normally people use WMK. So we can just get an idea what does it mean from this normalization part. Coming to the transliteration module, if we try to analyze, what happens is here is that those words which are being identified as belonging to the Punjabi language are being transliterated to Punjabi language. This is the statistics part Mukhtar has shown in the earlier slides. This is the last module where we have tried to combine both the outputs. So here in this, I have combined all the modules. For example, we can clearly see that the words are normalized also. Language is also being shown over here. And those words, transliteration part will include only those words which are of Punjabi language. And here we can see the sentiment analysis results. That's all. Any queries, please? Am I audible, sir?
Yes, Nitika, you're audible.
Okay, sir.
Okay, I know this is quite a challenging work, and you are doing a very good job over here. Just tell me what methodology you have used for this identification of this language.
Sir, I have used CRF suite. That will some contextual features have been incorporated in it.
And so what was the size of the training data for that?
For the time being, I have just used only 75,000 unique words.
Okay. So basically you are going at the word level. Now supposing I just give many of the words are basically now also being used commonly in both English and Punjabi.
Yes,
so
sir.
For example, it is good morning, sir. Breakfast table te lag gaya hai.
Yes, sir.
Just type it and let me see what output you'll be getting. Yeah. So good takes us English, morning is English, sir is English, breakfast is English. Table is in Punjabi also. You're saying table.
Actually, sir, that all will depend upon the amount of data which is being trained.
Okay.
So,
no, otherwise, how does it take that the table is English? How did it identify
actually,
that?
sir, I have tried to incorporate the Pi and Chan dictionary English US one.
Actually, table will be in the Punjabi dictionary also. This word will be there, na?
Yes, sir. Yes,
So
sir.
supposing the same word is occurring in both the dictionaries, then you take it as English or
Sir,
Punjabi?
actually, I have just tried to incorporate that frequencies are being stored. Those words which are occurring more frequently, if that word occurs more frequently in Punjabi, then it would be tagged as Punjabi.
So table will be otherwise if occurs more frequently in English, then you tag it as English.
For the time being, it is getting the frequency from Pi and Chan dictionary, because in my current tagged data, I have not put table inside that.
Okay, because I think you will find here a large percentage of words which will be common in both these English
Yes,
as
sir. Actually, in earlier one, I have tried to handle the ambiguities. I can.
car. A car is taken as English or as Punjabi? CAR car.
Just a second, sir.
You can just write over here, na. Road de upper car, motorcycle, the tractor khade han.
Okay, sir. Road de
ਉੱਪਰ ਕਾਰ ਮੋਟਰਸਾਈਕਲ ਅਤੇ ਟਰੈਕਟਰ ਖੜੇ ਹਨ। ਅਤੇ So road is English. Okay, road can be taken as English. Upper, it has taken as upper, huh?
Yes.
So that will also be issue where they could be.
Yes, sir. Ambiguities are need to be resolved in some particular.
Car also it has taken as English, na? Car is in Punjabi also. Motorcycle also. Ate is in Punjabi. Tractor is also khade. Khade test ignis kid.
Sir, actually, I have used just for the storage issue, I have used the Microsoft online transliteration tool over here.
But the khade actually, its translation is not proper. No? Khade is.
Yes, sir. Yes, sir.
Okay, just one last thing. If you instead of car, you just write kara. Kara should be then taken as Punjabi, na?
Expected, so sir.
N, yeah. So maybe it didn't translate.
Maybe, sir, I don't know. I can try it.
Try to write K instead of C.
Yes.
Yes. Okay. I know there are many challenges. I'm just trying to stretch your system. Otherwise, I know this is a very tough
I'm
task.
happy, sir. I'm able to handle some of the challenges.
No, but still you have done very good work.
Thank you so much.
Nitika, one quick question. Are we doing the proximity calculations here? Like, and seeing any English word, are we checking what are the proximate word left and right of that to see whether the same word, just like the example Mr. Lal gave, right, on the table?
Yes,
are we using that?
I have added this previous tag and next tag also in the while training the data.
So
for example, the road is in English and they is in Punjabi. So for they it will add the previous tag as well as the next tag as well.
Okay, but you are not scoring high or low based on the previous or the next word being in that one specific language.
Yes,
just a question on the table, being table in English or in Punjabi.
Yes, sir. Actually, those words which are common in both the languages, for example, as Lal sir was saying that car, motorcycle, tractor, these words are in Punjabi as well. But those words which are commonly preferable in English has been treated as English over here.
Sounds okay. Thanks, Nitika.
Thank you so much, sir.
Yeah, Nitika, this is also one good thing what we have digged out from the question and suggestion given by Mr. Sanjeev.
Yes.
So you can just have a window of 3 or 4 words or proximity of the words depending upon what language that word is in. So that can also be incorporated into this system. So you can just think on that.
That's a very good suggestion.
So any more questions from other session chairs, please?
Yeah, yes. Good morning, Dr.
Rajeev
and other session chairs and dear participants. Some of the suggestion from my side, to take the first word of this example, ROAD, instead of that one, ROD. What will happen?
ROD, sir, only?
Yeah. Okay. It's also in English. So in code mixed language, the most of the people normally using the not exact the transliteration. I had analyzed the code mixed language in especially in the case of the Malayalam kind of the languages, the most of the persons using
yes, sir.
Some of the short forms as well as not exact the English spelling.
Yes, sir.
How to handle these type of things? Then here is also a ROD instead of ROAD. Then how to handle these kind of the things?
For example, rod or road, sir?
Yeah.
Actually, I have not exactly think upon it because I was just, maybe I don't know, we are not going for the machine translation part, that is why we have not we are not going through the single word. Am I right?
No, not the single word, but the word forms for the code mixer kind of the thing.
Forms, sir. Short forms, sir.
Not exactly the short forms.
Yes, sir.
They are using the some of the, for example, car. CAR, the car is the correct one.
Yes, sir.
But some persons using KAR, it's also pronounced as car.
Yes, sir. For that, I'm trying to incorporate some spellings dictionary as well. For this, we have prepared 2 types of dictionaries. I am trying to just update this transliterated dictionary where we can handle these spelling variations.
Okay. The spelling variations, how to identify that one? It's a spelling variation or?
So that will depend. If it is of Punjabi, then we can use that from transliterated dictionary. For the English, I am just trying for some already embedded these spell checkers. For example, sim spell and all that. And then after incorporating these algorithms, for example, distance algorithms and all that, I have not just come up with exact what I would be doing for this.
Yeah. Okay. Actually, this thing is happened most of the cases in the case of the loan words.
Yes, sir. Yeah. That is very challenging. I am just onto it, but I have not just come up with proper what I can say that this is the best.
Yes. The loan words representation in local languages, especially in Indian languages. From English to Indian languages, that thing is totally different because some other cases they're using not exactly the short forms, but the spelling is totally variant from the exact English one.
Yes. That is there.
Yeah. To handle these type of things by using the separate dictionary or some other special algorithms to, I think, need to be.
Yes, sir. The combination of actually, I was just thinking that I would be using different algorithms there. Also, there's suggestions plus then performing some common. For example, they are giving some distance, then adding all the variants and some numerical value may be helping that.
Yeah. Okay. Then one more thing. It's English to Punjabi, but if we are using this one for the trilingual languages like English, Punjabi, and Hindi, there is a lot of chances to mixing the Hindi, English, and Punjabi languages together in a single sentence. Did you check it with?
No, sir. I did not check that with Hindi.
Yeah, maybe a chance for that one, but I don't know whether Dr. Vishal Goyal.
Yes, sir.
Yeah. That how to handle the trilingual means English, Punjabi, Hindi. The code is that means code mix.
I think some modifications will be required. Otherwise, in parallel, Hindi dictionary can be added over here. So same algorithm will work over here as well.
Yeah. Yes, maybe.
So after
maybe a chance of ambiguity. Maybe a chance of ambiguity will be there. Is it right?
Yeah. So now Nitika is going to be the Dr. Nitika in coming days. So after that, she can guide other students on this, topic.
Okay.
Am I right, Nitika?
Thank you so much, sir.
Yeah, great. Advance congratulations to Nitika.
Thank you, sir. Thank you so much.
Okay. Any more questions from any other session chairs, please?
Sir, if I may add something.
Yeah, please, yes.
Nitika, please, can you go down a little bit?
Yes.
Like we are seeing that road ਦੇ ਉੱਪਰ ਕਾਰਾਂ ਤੇ ਮੋਟਰਸਾਈਕਲ ਅਤੇ ਟਰੈਕਟਰ ਖੜੇ ਆ. It's giving the sentiment result for English sentence. Isn't it possible to add the Punjabi words to that? Because after the language identification, we can transliterate and add the Punjabi words to that.
Yeah, we can do that.
Yeah, it would be a little bit easier on the dictionary side to create a less amount of dictionary for the same result.
Yes, that is possible. Actually, in my individual tool, I had just making a simple module that would transliterate every word of English into Punjabi.
No, I mean, like you are giving language identification for these 8 to 10 words.
Yes.
That transliteration part is having English or Punjabi depending on the language.
Yes.
If we combine that sentence Means in sentiment analysis results, the road will be in English as per the output.
Yes.
Day will be in Punjabi.
Yeah.
Upper will be in English. Kara will be in Punjabi.
Basically you display in the output as it is, like it is, if it is in Punjabi, like in the first paragraph you are displaying day in day, right, in Punjabi. So here in the results you mention day over here, right, in Punjabi.
Yes, sir.
Okay, yeah. That's
It will look nice. So you can just modify. It's a small change over here you can do. Otherwise you can take the help of Jitesh in modifying this if you are not able.
Okay, thank you, Jitesh, for your suggestion.
Yeah. Yeah. And
Okay.
good luck.
Any more queries, please? Okay, so moving. Thank you, Nitika. It's nice presentation and demonstration. Nice product. So moving ahead, I am calling upon Manpreet Singh Lahal. Manpreet Singh Lahal. So he'll be presenting on the topic extracting parallel phrases from comparable English and Punjabi corpora using an integrated approach. Manpreet Singh Lahal, share your screen, please.
Okay, sir. I am audible?
Yes.
So I am Manpreet Singh, pursuing my research under the able guidance of Dr. Vishal Goyal, Dr. Ajit Kumar. Or my topic is extracting parallel data from English to Punjabi comparable corpora. And we develop a software which extract the parallel data. So this is the site I have developed to present my work. And this site contains 3 tools, crawler, extractor, and all-in-one. So basically all-in-one is integrated or crawler and extractor. So I explained one by one. Now what is the crawler? I open in the new window. So in the crawler, on the screen, you can see the input box, drop down, and crawl button. You just provide the link of the web page in the yes we find this is the link of Punjabi University. Control C, then I paste in the link, and then we click on the crawler. So if we copy the then we hit the crawler, and after this the crawl will be crawl the Punjabi and English text data from the web page, and the output can be seen in the separate English and Punjabi text boxes. And in the drop down button you will find the further link on the web page which can be selected. Just wait, it takes some time according to the data in the web page. So in this web page only this data, now this is working. So you can say, okay, this is the Punjabi data and this is the English data from this web page. Now you can see here is the further links on this page. For example, about the Patiala city. So this is a link on this web page. I select this in, suppose that about the Patiala, and hit the crawl button, and they will crawl all the data from this page. Crawl the data of this page. You will see here is a lot of data, and it take some time according to the availability of the data in this page. So at the meantime, I will open another tool is called extractor, and it open in the new tool. So the extractor is a second tool. Meantime is running. So the second tool is the extractor. In this tool, we copy and paste the data of English and Punjabi, which is the output of the extractor. Here is output of the extractor. This is the Punjabi and English data, and we will provide to the extractor tool. So what is the purpose of the extractor? Extractor tool will refine the data, and also it extract the parallel data, which is aligned data in the aligned output. So the extractor tool extract the parallel data from the given comparable data. So basically this extractor give a comparable data. So this comparable data put in the input Punjabi box and English input box, and this extractor tool align this extractor tool. Now this will work. So if we copy this data, Punjabi data, Control C, and paste Control V, and the English data, and Control C, in the English Control V, and here is the tuning button. The tuning button help to give the required level of the similarity. If we increase the tuning, then we will get the sentence similar at the phrase level, and mean is partially similar. Now click on the submit button. Click on the submit button. Now I will see. Okay, here is the Moti Bagh Palace. Control C, and if you find this sentence on this page, Control F, Control V. So this is the line is extract from this web page about Patiala. So it takes some time, and the extractor will give the parallel sentence between these two input. So what is the parallel? Which is the exact translate English or Punjabi into comparable corpus. So at the meantime, I open the third. I think it's work. So now you can see. So this extractor also see the number of lines in the Punjabi sentence is 138, and number of lines in the English is 163, and the output in the aligned data. So 60 match with the 2. So about us, this bus stand ਇਹ bus stand ਪਟਿਆਲੇ ਦੇ ਬਹੁਤ ਨੇੜੇ ਹੈ. So about this, the situated very close to the bus stand Patiala. So Chandigarh Hawaii Adde to kuch Bharati airlines. So the Chandigarh airport is the domestic airport and have flight to the some Indian city. So this is a work of extractor tool. It extracts the parallel data from the comparable corpus. Now this we can combine these data in the extractor tool, crawler and extractor all in one. If you just copy the data link of this Punjabi University Patiala and give to the third tool and paste it and click on the submit button. Now in the all-in-one tool, we can separate this aligned data into two files, English and Punjabi, and which is very useful for the translate. So in the all-in-one tool, just you paste the link and it gives the three outputs. One output is the aligned data as the extractor tool, and second output in this text box, these are the two parallel lines, the two parallel files, English and Punjabi. Yes. Wait. Once it's done, you can align the output data, and the output is broken into separate files, English and Punjabi, and these files are completely parallel to each other and have the same number of sentences. Just wait, it working. or these files are sent as the attachment to by the tool at my mail to collect the parallel data. After it completed, it will give a mail at my email is a okay. Refresh. Now here is give a 2 emails Friday, December. If we download it, I will see it download on a desktop, and second file also download and open it this. So the naming of the file according to the date and time, it moved to another clone. No. So Punjabi text. मैं थोड़ा zoom करता हूँ इसको. Now this tool will give a 2 parallel data. So the Chandigarh airport is domestic airport and first line will be the Chandigarh Hawaii Adda to kuch bharati shehran li udana han. So this extractor tool to collect the parallel data is collect the parallel data from the comparable corpus. So here is a aligned data, and we separate this aligned data into 2 different files, Punjabi and English. And you will see here is a 49 lines is parallel with the 49 lines. So this is our output, and this output for the collection so on this collection here is a mail. Or thank you, sir.
It was nice demonstration and exhaustive demonstration. So I invite the session chairs to please ask the questions, please.
Okay, Manpreet, it's quite an interesting work and very useful resource is being created by you, which actually will be very useful for machine translation. And I was just wondering why you're having 2 files. Why don't you have it, say, just like Excel sheet where you will be having next to each other, so that otherwise also it's fine, but that will be more easier later on. You could just have an XML file where you have first sentence in Punjabi, then the next sentence in English, because that will be easier for any program if they want to then use it.
Yes, sir. I will.
That's not a big deal. No, that's not a big deal at all. But I'm just thinking that if you have an XML file in that format, that will be more useful. That you can very easily do. I know that. That was just a simple suggestion. So, did you try this on Wikipedia, where you had Punjabi? Some articles actually are quite similar to each other over there. Have you tried it over there? Punjabi and English Wikipedia.
Basically, he has taken the data from Wikipedia itself, and it has been tested on Wikipedia also.
Okay, because that's a big resource. And so, what is the total size of the parallel data now you have extracted?
So near about 14 lakh sentences which were trained to this our system. 14 lakh sentence. 14
lakh. Okay, that's very good. 14 lakh sentences now you have in the parallel data.
Parallel data to train this system.
That's very good. Okay, I just have just for testing purpose, I'll just be giving you 3 simple sentences. Can you just type them over here? Okay, you can have in Punjabi say Ki hal hai? Then question mark. Oh, so typing.
Typing मेरे को पंजाबी.
No, you can very easily. Okay, then you can just use this Google translation tool. So no, I then just give you simple sentences in English only. You translate in Punjabi or then you can just jumble the sequence. That's what I just want to see. You may just use that online Google translation tool itself, so that you don't have to type Punjabi over there.
I type is ki hal hai.
No, you just use translate.google.com. You just go over there so that you don't need to type in both the languages, na?
Okay.
Yes. So you just type in English only. How are you? Question mark. Then next is आज स्कूल जाना है नहीं are you going to office today
or
are you going to office today going then next is where are you where are you then just last one is why then we can just take this and then just jumble the sequence over there na? And now you can take these four in the same sequence.
Okay, sir.
Oh, okay. In this tusi na, you can just delete this extra dot. Third sentence. Yes, just write it.
This is the parallel sentence. How are you? तुसी केमे हो? 3
Yes.
match with 1 and 4 with 2.
And what about the next two?
Just wait, we increase the tuning. Just measure Control C.
ਕਿੱਥੇ ਦੇ ਅੱਗੇ ਐਪੋਸਟ੍ਰੋਫੀ ਹੈ ਇਹਨੂੰ ਠੀਕ ਕਰ ਲਓ ਜਰਾ ਉਹਦੇ ਕਰਕੇ
ਠੀਕ ਕਰ ਲਓ
ਨਹੀਂ ਤੁਸੀਂ ਸਪੇਸ ਪਾਓ ਸਪੇਸ ਤੁਸੀਂ
no you have deleted one
ਬਿੰਦੀ ਤੁਸੀਂ ਦੇ
ਵਿੱਚ ਉੱਪਰ ਵਾਲੇ ਵਿੱਚ ਵੀ ਨਹੀਂ ਹੈ ਬਿੰਦੀ is missing in the ਦੂਸਰੇ
ਜਿਹੜੀ ਦੂਸਰੀ ਲਾਈਨ ਦੇ ਵਿੱਚ ਤੁਸੀਂ ਹੈ ਨਾ ਉਹਨੂੰ ਕਾਪੀ ਮਾਰ ਲਓ ਠੀਕ ਕਰਕੇ
ਫਸਟ ਇਸ ਥਰਡ ਦੋਨਾਂ ਵਿੱਚ ਹੀ
ਨੀਚ ਨਾ ਸੈਕੰਡ ਲਾਈਨ ਚ ਤੁਸੀਂ ਨੂੰ ਚੱਕਣਾ ਹੈ
ਉਹ ਫਸਟ ਤੇ ਥਰਡ ਵਿੱਚ ਉਹ ਪਾਉਣੀ ਹੈ ਫਸਟ ਵਿੱਚ ਵੀ ਮਿਸਿੰਗ
ਇਸ ਤਰ੍ਹਾਂ
ਕਾਪੀ
ਉਹ ਨਹੀਂ ਇਹ ਵੀ ਗਲਤ ਕਰਤੀ
ਕੰਟਰੋਲ Z ਨਹੀਂ ਬੇਟਾ ਤੁਸੀਂ ਦੇ ਵਿੱਚੋਂ ਕਾਪੀ ਕਰਨਾ ਹੈ ਹਾਂ ਠੀਕ ਕਰ ਰਹੇ ਹੋ ਹੁਣ ਉੱਪਰ ਵੀ ਕਾਪੀ ਮਾਰ ਦਿਓ ਤੁਸੀਂ ਦੀ ਥਾਂ ਤੇ ਰਿਪਲੇਸ ਕਰ ਦਿਓ
ਫਸਟ ਦਾ ਫਸਟ ਵਰਡ ਹਾਂ ਇਹ ਵੀ ਹੋ ਜਾਏਗਾ
ਇਹਦੇ ਅੱਗੇ ਨਾ ਮੇਰੇ ਖਿਆਲ ਐਪੋਸਟ੍ਰੋਫੀ ਪਿਆ ਹੋਇਆ ਹੈ
ਯੈਸ
ਇਹਨੂੰ ਤਾਂ ਪਲੇਸ ਕਰੋ ਪਹਿਲਾਂ ਤੁਸੀਂ ਇਹਨੂੰ ਠੀਕ ਕਰ ਦਿਓ ਉੱਪਰਲੇ ਨੂੰ ਹਾਂ ਇਹਨੂੰ ਠੀਕ ਕਰਨਾ ਹੈ ਪਹਿਲੇ ਵਾਲੇ ਨੂੰ ਠੀਕ ਕਰਨਾ ਹੈ ਪਹਿਲੇ ਵਾਲੇ ਨੂੰ ਤੁਸੀਂ ਕਿਵੇਂ ਹੋ ਨਾ ਤੁਸੀਂ ਗਲਤ ਹੈ ਉੱਥੇ ਬਿੰਦੀ ਪੈਣੀ ਹੈ ਨਾ ਸੈਕਿੰਡ ਵਾਲੇ ਚੋਂ ਕਾਪੀ ਮਾਰ ਕੇ ਹਾਂ ਪਹਿਲੇ ਵਾਲੇ ਚ ਕਾਪੀ ਮਾਰ ਦਿਓ ਹਾਂ ਹੁਣ ਕਿੱਥੇ ਦੇ ਅੱਗੋਂ ਅਪੋਸਟ੍ਰੋਫੀ ਹਟਾਓ ਬਸ ਹੁਣ ਚੱਲ ਕੇ ਦੇਖੋ ਹੁਣ ਕਰਕੇ ਦੇਖੋ
ट्यूनिंग जीरो करके देख लो यार जीरो तो पहले दे रहा सीगा वो
एक्चुअली ट्यूनिंग के ऊपर जीरो दे तो वो देगा वो
हाँ
एक्चुअली we refine the data ना exact parallel sentences जेडे if you find
चेक करना राजी क्यों प्रॉब्लम आ रही है
नहीं सर ऐसा नहीं है प्रॉब्लम नहीं है इसमें ऐसा है कि जब ट्यूनिंग हम इंक्रीज करते हैं ना इसकी
तो रिजल्ट ही नहीं आ रहा है ना कोई भी वी आर नॉट गेटिंग एनी रिजल्ट फॉर दैट
3 is matched with the 1
that's fine but the other two are also very straight simple ones they should be
simple ही आने चाहिए थे ना रिजल्ट ਦੇ ਵਿੱਚ
okay no problem but it's a challenging work I know good thank you
okay any other queries from other session chairs please participants
I'm good
okay so thank you very much Manpreet it was a nice presentation nice work so let's move to Mr. Kapil Dev Goyal yes Kapil Dev Goyal am I audible to you unmute yourself Kapil Dev Goyal please unmute yourself
Hanji good afternoon sir
good afternoon share your screen so the topic of Kapil Dev Goyal is design of hybrid algorithm for automatically identification and extraction of multi-word expressions from English Punjabi monolingual and parallel corpora. Yes, Kapil, share your screen, please. Yes, fine.
Good afternoon, everyone. My name is Kapil.
Don't show the presentation, show your software directly.
Yes, sir. This is an interface of my tool. There are various tabs. In first tab is Punjabi monolingual multi-word expression, and in this tab we can extract monolingual Punjabi multi-word expressions. And next tab is English mono multi-word expression. Using this tab we can extract English monolingual multi-word expression. And next tab is bilingual multi-word expression. And in this section we can extract parallel Punjabi English multi-word expressions. And next tab is corpus tool. These are various tools uh, which are used for extracting multi-word expression. And next one is NLP tool, and these tools has been implemented in my work, and these tool is used for extracting multi-word expressions. For example, English to Punjabi transliteration system, Punjabi to English transliteration system, Punjabi part of speech tagger, English part of speech tagger, Punjabi stammer, English stammer, Punjabi chunker, English chunker, and last one is English NER. And last tab is other tab, and this is for other purpose. And today I will discuss only bilingual multi-word expressions. And in this section, we can extract parallel English Punjabi multi-word expression. First of all, we will choose the Punjabi text file and English text file. I have already created English and Punjabi parallel sentences. Yes, I have already created parallel English and Punjabi sentences, and using these sentences, we will extract the multi-word expressions from these expressions. And first, we will extract the Punjabi replicated multi-word expressions. Yes, in the third column, we have results of replicated Punjabi multi-word expressions along with their English translation. We can download these results by clicking on this button, download output file. And these are results. Left hand side of the hash button, we have replicated Punjabi word, and right hand side we have English parallel translation of each multi-word expression. And next category is word combination with antonym. And in this category, we will extract a word combination with antonym multi-word expressions. These are results: Labani, Chota Badda, Nark Swarg, Sukh Dukh. These are word combination with antonym, in which second word is antonym of first word, and these are results along with the parallel English translation, and these are results. And next category is word combination with hyponym. Yes, these are results in which second word is hyponym of first word, and in some sentences, for example, Chota Mota, Mota is hyponym of Chota, and Mota has no sense. That means only Chota has English translation. Chota Mota means small, and these are results of a word combination with hyponym along with English parallel translations. And next category is Vala morpheme. Vala morpheme Morpheme multi-word expressions has various morpheme variations. For example, vale, valia, vale, vala, and these expressions can be multi-word expressions. And these are the results of morpheme expression along with parallel English translations. And next category is name entities. These are parallel English Punjabi sentences. Now we will extract the name entities. Yes, these are the parallel name entity. Ram, Ram, Kapil Dev, Arjun, Arjun, Ram, Ram Sham, and these are the parallel English Punjabi name entities. And next category is extract the unaligned words. For example, in English, ਅੱਖਾਂ ਦਾ ਤਾਰਾ. In Punjabi sentence, Ram ਆਪਣੀ ਮਾਂ ਦੀ ਅੱਖਾਂ ਦਾ ਤਾਰਾ ਹੈ, and in English parallel English sentence is Ram is very dear to his mother. And in this ਅੱਖਾਂ ਦਾ ਤਾਰਾ is unaligned word to the very dear, and these are the parallel translation. ਅੱਖਾਂ ਦਾ ਤਾਰਾ means is very dear to. Next, आग बबूला हो जाना, and its parallel translation is angry after. And these are the outputs of results of the unaligned words. Next category is noun plus verb combinations. Noun plus verb. ਵਿਆਹ ਕਰਵਾਇਆ, ਖਾਣਾ ਪਕਾਉਂਦੇ, ਘਰ ਬਣਾ. These are the noun plus verb combination along with their English translation. Next category is adjective plus verb combination. I think there is no such combination, adjective plus verb combination. Let us try next. Next category is adverb plus verb combination. I think last one is compound verb. Compound verb, both are the verbs. Compound verbs देख के, हो गया, बना लिया, along with their English translation. And next type is Punjabi monolingual multi-word expression. And in this tab, in this section, we can extract the monolingual Punjabi multi-word expression. Let us choose the Punjabi file. And in this section, we can extract the replicated expression, we can extract the linguistic patterns, we can extract multi-word expression using the statistical method. And first of all, we will extract the pure replicated word. These are bar bar, jaldi jaldi, naal naal, dodda dodda. These are the pure replicated multi-word expression. Next category is hyphen separated multi-word expressions. Kade kade, var var, khushi khushi, khariyan khariyan. These are also multi-word expressions. Next is particle containing multi-word expressions. For example, kuj na kuj, kite na kite, koi na koi, puri to puri. These are the particle containing multi-word expressions. Next, word combination with antonym. Lavani agge piche. Similarly, verb combination with hyponym. Tutte futte, tutti futti, tutte futte. These are the word combination with hyponym. And last one is wala morpheme. सौन वाले कमरे, हिंसा वाले, पिंड वाले, पुलिस वाले, पूर्णमाशी वाले दिन. These all are the wala morpheme multi-word expressions. And similarly, in case of a linguistic method, we can extract the following linguistic pattern: name entities, noun plus noun, adverb noun. Then in case of conjunct verb, we can extract following linguistic pattern: noun plus verb, adjective verb, adverb plus verb. And in case of compound verbs, these are compound verbs, and these can be multi-word expressions, candidate for the multi-word expression. And in a statistical method, these approaches are mainly used for the collocation extracting. And we have used these all the tools: point-wise mutual information, extended point-wise mutual information, log likelihood ratio, extended log likelihood ratio, dice coefficient. And we also create a hybrid approach by combining these approaches, and the results of hybrid approaches. Yes, these are the results of hybrid approaches. These are the multi-word expressions: yes, apyash, khalandi plandi. This is dota doti. These are the collocations: tutta futta, mangetar mangetran. These are the multi-word expressions. Now, in case of linguistic, English multi-word expression, we will choose the English file.
Yeah. So Kapil, I think similar English multi-word expression will be there.
Yes, sir. Mostly.
Can you just brief in very less time, just 1-2 minutes?
Yes, sir. Yes, sir. Actually, I have discovered two new types in the English multi-word expression. Two types of multi-word expression I discovered. First one is hyphen separated. Words are separated by hyphen, then they can be multi-word expressions. Supposed doctor-in-law, son-in-law, super long. These are the hyphen separated multi-word expressions, and these can be multi-word expressions. And another category I have discovered that English samas. Samas means combination of two words. Get away and lightweight. These are the English samas. If we combine these two words, get away, then it becomes a new words. Similarly, if we combine light and weight, these two words, then it becomes also a single word, and these words can be multi-word expressions. Similarly, we can extract same as Punjabi linguistic pattern, and similarly using statistical method, we can extract the multi-word expressions in English. Thank you so much, sir.
Yeah, over to the session chairs, Dr. Sanjay from Central University, Lucknow. Dr. Lehel, any queries, please?
No, it's fine. This is a good collection of tools which have been developed by Kapil. So very nice.
Thank
I
you, sir.
appreciate it, but otherwise I don't have any query from my part. Thank you.
Thank you so much, sir. Thank you so much.
Yeah. Any more queries from other session chairs, please? Or are there other participants?
Yes,
Yes, please. Dr. Rajeev, yes.
yes.
Yes, Dr. Rajeev, you are not audible, please. Kapil, can you stop sharing the screen, please?
Hello.
Yes, Dr. Rajeev, please continue.
Yeah, it's a good effort. Actually, he did a very good effort to develop this tool for extracting the multi-word expressions. And then no more questions from my side, because here is I think some network issues. Is it audible from my side?
Yeah.
Hello.
Bit disturbance is there, otherwise you are audible. Bit disturbance, otherwise audible.
Okay. Continue with the next question.
Okay. So if there are no queries, so we will take a break for lunch. So no doubt it should be from the icon, as it is a virtual conference. So we need to go for the lunch by ourselves. So, thank you very much to all of you for joining us in the first session. So we will be joining back for the second half of the demonstration session at 2 p.m. I am really thankful to all the participants and the session chairs who has made this session very knowledgeable, and a lot of feedbacks has been given to the participants for improving their systems. So thank you once again. Thank you very much. So we'll be joining back by 2 p.m. Thank you. Bye-bye.
Okay, thank you, Vishalji. Then we will meet.
Vishal sir, should I make you the host?
Yes, anybody has asked something?
Yeah, I asked, should I make you the host now?
Sorry, please come again.
I'm asking, should I make you the host now, sir? Currently.
Yeah, please. Thank you. Yeah.
Sir, are you able to access now?
Yeah. Thank you.
Yeah, thanks.
So very good afternoon, Professor Amba Kulkarni ji.
नमस्ते सर।
नमस्कार मैम, नमस्कार। बहुत देर के बाद आपसे बात हो रही है। कैसे हैं सब? बढ़िया?
बस सब बढ़िया है।
चलो बहुत अच्छा है। और बच्चे सर बढ़िया हैं सब? बढ़िया?
Everything is fine. Yeah.
That's so nice of you.
It's good that we have this virtual, at least virtual conference this time.
Yeah. So we have not missed the icon.
Right.
At least we have celebrated this icon. So and it's a good platform.
That's very great. Yeah. And you have got very good participation for the demo session also.
Yeah, ma'am.
I didn't know about this. Somehow I missed it.
But we have the recording. I can share you the recording.
No. Not about the announcement itself. I missed.
Oh, okay. Otherwise, I was publicizing a lot. I don't know.
But somehow I missed it. I didn't notice it. Anyway, it's going on great.
Oh, thank you, ma'am. But it's really good if we can come to know about the working systems, and in future people can use it.
Very good initiative, and I liked it very much.
Thank you, ma'am. I think about 17 to 18 demonstrations are there in the full session.
Yeah, morning I missed because I was traveling, so I could not attend. So I thought I will join post-lunch session. So now.
No, that's great, ma'am. Definitely. Thank you. So nice of you for joining.
तो पंजाब में ठंड कैसी है इस बार? ज्यादा
आज तो बड़ी ठंडी है। अप्रोक्सीमेटली 8 to 9 डिग्री टेम्परेचर है।
हाँ। वैसे सुना अभी इस बार सब जगह ठंड थोड़ी ज्यादा ही है।
हाँ, इस बार ज्यादा ठंड पड़ रही है मैम।
Even in Hyderabad we feel it's cold.
Oh, is it? Okay. Otherwise हैदराबाद में तो ठंड होती ही नहीं है।
हाँ, हमें स्वेटर निकालना ही नहीं पड़ता इस बार हमने निकाला स्वेटर बाहर.
ओके चलो आपको भी अब नॉर्थ की फीलिंग ले रहे हैं.
Yeah. So we are starting now.
I'm waiting for the participants to join. 1-2 participants have joined, so I'm just calling. All should join so that we can start.
Yeah, yeah. At least the presenter should be there.
Yes, ma'am. Yes, ma'am. So I think let we start from Kamaldeep. So Kamal, are you ready?
Yes, sir. Good morning, sir. Good afternoon, sir. I'm ready, sir.
Okay. So Kamal, you can share the screen and you can start your demonstration. So I welcome Professor Amba Kulkarni ji from University of Hyderabad. I don't think I need to give any introduction for her because she is the renowned personality in the NLP community. So we are starting with the first demonstration of this second half. The topic of the demonstration is design and implementation of corpus-based machine translation system for Punjabi to English. So Kamal, please share your screen and explain your system.
Good afternoon, everyone. My name is Kamaldeep. I am currently pursuing my PhD under the guidance of Dr. Rajeev Kumar and Dr. Vishal Goyal, Punjabi University, Patiala. Under their guidance, I have developed the machine translation system for Punjabi to English as well as for English to Punjabi by using the neural machine translation approach. So this is a...
Join kar lo. Join karo beta. Next part here.
So this is an interface. This interface is developed by using the is developed in Python by using the Flask. So now firstly I will show some text by translation. These are the sentences of English text. Now we will select the proper model. Actually, this is coming. Actually, I have installed a Grammarly. That's why it's showing the red line here. Now, when we click, the model will be run at the back for English to Punjabi. It will translate, and then the output will be given in the next box. So, like former SGPC member joined app. So here app is a app can be a here app is a party. So and my system correctly translate into a app. ਸਾਬਕਾ ਸ਼੍ਰੋਮਣੀ ਕਮੇਟੀ ਦੇ ਮੈਂਬਰ ਆਪ ਵਿੱਚ ਸ਼ਾਮਲ ਹੋਏ. So firstly I have developed the model, a very simple baseline model of the neural machine translation system. In that model this app is translated to app A, but I have used the dynamic byte pair encoding as well as a word embedding to improve the translation of my system. Like next, the Indian Army to utilize effectively ਭਾਰਤੀ ਫੌਜ ਨੇ ਪ੍ਰਭਾਵਸ਼ਾਲੀ ਢੰਗ ਨਾਲ ਘੁਸਪੈਠ ਕੀਤੀ। Next, like type 2 diabetes grow gradually. So I have taken the data from the news domain, from the health domain, from the agriculture domain for the testing. Like this is the health domain data. Type 2 diabetes grows gradually. So it had translated into the type 2 diabetes holi holi vad jandi hai. Same, these are the some of the example translations from the English to Punjabi. Now in the last, like, don't forget the measles vaccine at the end of a 9-month. Here it's showing the no and there the two signer coming at the rate. Actually this is due to because I have used the byte pair encoding, and there is a little bit code. After this it will be also removed from here. Now I will show the in the reverse direction, like for Punjabi to English. Now again we will select the proper model. For the Punjabi we also need a tokenizer, so I have created a tokenizer by myself. So again, so first the tokenization completed at the back end, then the model will be a neural machine translation model will be executed, and it will convert my Punjabi text to English and give to the text box. So this is the output. Again, I have taken the data from the news domain, health domain, and different domain. Like Abu Shakki Atwadi, Abu is a suspect. HIV की है? What is HIV? Next, परिवारिक member अनुसार हिल बीमार है. So according to the family member, Hill is a sick. So by using the corpus-based approach, I have developed the Punjabi to English and English to Punjabi neural machine translation system. This is all from my side.
So queries from the participants. Dr. Amba, ma'am, any queries, please?
Yes. So how big is your corpus?
Ma'am, my training corpus approximately contains 6 lakh sentences, ma'am.
Achha, 6 lakh parallel sentences.
Yes, ma'am. 6 lakh parallel sentences, ma'am. So this I have also, Manpreet sir has also created a comparable corpus. From that comparable corpus, I have also taken a Punjabi to English sentences. Kapil sir has also created a multi-word expression. So from that multi-word expressions, I have also taken a data for the multi-word to embed into my corpus, and I also have created the manually. Actually, I downloaded the corpus, the TDIL corpus. We have Brill's corpus we have, so I have manually done the pre-processing work to make the corpus ready for the training purposes.
Yeah. So all these together is 6 lakh sentences.
Yes, ma'am. Yes, ma'am. All together.
That's sentences or words?
No, ma'am. Sentences. I can show, ma'am.
Okay. No. Just I'm asking.
Yeah, sentences, ma'am. Sentences, ma'am.
Fine. Because I missed it, so I again asked whether.
No, ma'am. No issue.
Yeah. Fine.
Well, rather, we have manually corrected all the sentences. So Kamal has corrected all these sentences correctly manually, so that all the sentences are correct.
Yeah. And what about the punctuation marks and other things? You are ignoring them, or in the input text, parallel text, you have all the punctuation marks?
Yes, ma'am. Yes, ma'am. I'm not ignoring. Actually, they have tokenized, ma'am, properly for Punjabi. That so there should be some space between us. Each punctuation will be taken as a separate token, ma'am.
Right. Okay.
Even, ma'am, in the last session, we have worked for the multi-word expressions as well. So all type of multi-word expressions we are able to extract from the parallel as well as manual corpora. And in one system, what we have done is we have taken the comparable corpora of English and Punjabi, and we are automatically extracting the parallel sentences out of the comparable corpora. And we are getting 80 to 90% of correct parallel corpora out of that.
Okay, now the input that you have given is from the corpus, or is it is from outside the corpus? Which
yes, ma'am. Input is.
Yes, Kamal.
Yes, for this, sir, I have tested with my input from the corpus. Actually, but I have created a 3 set, ma'am: a training set, validation set, and the testing set, ma'am. So
no,
by using
that is fine. But suppose you give some input from outside the corpus. what is the how good are the results?
Ma'am, then I have checked, ma'am. If the that is related to our domain, like then it will be a translated correctly. Otherwise, it will be not translated, ma'am. Because this is a corpus-based system. As if we have a more corpus, then we will because because based on a corpus, dictionary is that word that is used here.
That is true. So suppose I gave a new sentence for which all the words are in the in your dictionary, suppose, okay, then how good? So if you can test it, if you can demo it with some sentence which is not there in your corpus, how good the translation would be?
Ma'am, I can show, but ma'am, it also depend upon some words are interrelated with each other. So if it will found in that corpus, based on that dictionary, it will give the translation. Otherwise, ma'am, it will give us some dummy translation.
Yeah, fine. Just out of curiosity, I want to know. So
okay, ma'am,
you can give some sentence. Okay.
Okay, ma'am. Sure, I will.
Today I am demonstrating my tools to the icon audience.
Okay, ma'am.
Suppose we give this sentence and English to Punjabi. Today I am demonstrating my tools.
I am
TRAT. Yeah.
My tool on.
No, tool on NLP, or yeah, you can add tool on to icon. Okay. On NLP, fine. This is also
okay.
Okay, so what is? Will you read this?
Actually, ma'am, this is a wrong translation, ma'am.
Okay, but what it has produced, will you read it?
It's showing Pandit Radicalus अपने संद नु प्राप्तता दिखा रहा है, दिखा रहा है.
Demonstrating दिखा रहा है, it has done.
हाँ जी मैम, हाँ जी मैम.
Yeah.
Actually, ma'am, like the word. हाँ जी मैम, NLP is not in my corpus, ma'am.
Okay, fine. But today has it translated correctly?
No, ma'am.
No. Okay.
It only shown them demonstrating.
Okay, fine. Demonstrating is good.
Yeah, and this nu yes raha hai. That this is a present tense, ma'am.
Yeah.
And this
demonstrating.
हाँ जी ma'am. And this dot into a viram symbol in Punjabi.
Oh yeah. And my tool it could not do, right?
No, ma'am. My is apne, ma'am. My is apne. That is okay. Tool is also done, ma'am. Tool is sand in Punjabi.
Okay.
Hathiyar. My tool is sand, ma'am.
Okay, so apne. So all this it has done.
Yes, ma'am.
Okay. Only on NLP and today. These
today, ma'am. Yes.
Today, if we maybe put it at the later, I am demonstrating my tools on NLP today. If we do.
Yes, ma'am. I will.
No. Because normally in English, this will come later. Today will come later. NLP today. So let us see how it works.
No, ma'am, it is giving us same translation, ma'am.
Acha.
Actually, this is
fine,
not any.
Fine. Okay.
But Kamal, can't we transliterate? Why it is giving picking some wrong words arbitrarily, randomly? How it is picking the words?
Yeah, actually, these if everything is in capitals, that means it is an acronym, or so yes. You can just keep it as it. Maybe this is a good suggestion, Vishalji.
Yeah. Okay, yeah. So Kamal, please incorporate it, right?
Okay, sir.
And arbitrary anything can Pandit, from where the Pandit has come over here?
Actually, sir, this make the dictionary and a neural model by itself, sir. So automatically it has picked, sir, from there.
Okay.
Actually, and sir, actually we cannot see what will be a prediction, sir, in this encoder decoder approach. What it will take, sir.
Okay, fine. Any more queries, please? Okay. Thank you, Kamal. Thank you very much. So next we are moving to Mr. Nitin Bansal for Punjabi to Urdu machine translation system.
Good afternoon, everybody. Am I audible, sir?
Yeah, good afternoon. Yeah. Please share your screen and start the demonstration, please.
Okay, sure, sir. Sir, is it visible? The screen is visible?
Yeah, screen is visible, yes.
Can you see it now?
It's fine. You start your demonstration.
Good afternoon, everybody. Today I'm here to demonstrate a Punjabi to Urdu machine translation system, which has been designed using the hybrid approach. I have developed this system under the esteemed guidance of my guide, Dr. Ajit Kumar. But I cannot forget to mention the kind of support I got from the Punjabi University Language Department, Dr. Vishal Goyal and Dr. Preeti Singh Lahal also. So today I will just show you the glimpse of how this system works. Initially, I just want to say that there was no such work was done earlier on Punjabi to Urdu machine translation system. But Urdu to Punjabi is available. You can see here that Urdu to Punjabi is available on online also, right? Sorry, you can see this, but Punjabi to Urdu was not available. So today I will demonstrate how my system works using the hybrid approach, where I have used the statistical statistical data as well as the rule-based approach. Both the approaches I have used in this system. For example, let's go to the one website called as bbc.com/Punjabi. Now, bbc.com/Punjabi will give me the Punjabi text. For example, this is the today's page. So I'll just click on this and let me just copy the data from here. And let me paste on the system. This is here. And here I'm having three options. One is translate, one is transliterate, and one is quit. So using translate, it will help me to translate the whole text. For this, I have taken a corpus of size about more than 1 lakh sentences, and parallel corpus has been designed for this purpose. Moreover, to handle the out of vocabulary words, I have used the .NET system, from where we have tested initially for making it web-based system initially. Then I have transformed this web-based system into the Perl programming, so that I can combine both translation and transliteration tools. So this system has been designed totally on Moses nowadays, but I'm working on making it web-based also. So here you can see that I have copied the data from website. Kendri Khetibadi Mantri Narendra Singh Tomar ne Veerwar nu Kisana nu. This is the latest trend going on, and it has converted it into the Urdu text. Now, since sometime we are not able to understand Urdu, but here let me just take it into the Urdu to Punjabi machine translation, that whether it has corrected correctly or not. Because the accuracy of Urdu to Punjabi is about more than 85 to 86% is there. So the data must be correctly translated here. Am I audible, sir? Vishal, sir?
Yes.
Okay. So you can see that, sir. Kendri Mantri Kheti Badi. So I just comparing it with my input. So you can just compare the above two sentences. Kendri Mantri Khetibadi Narendra Singh Tomar ne Veerwar nu Kisana nu ek 8 ਸਫ਼ਾ ਦੀ ਖੁੱਲੀ ਪੱਤਰ ਲਿਖ ਕੇ ਜਿੱਥੇ ਨਵੇਂ ਖੇਤੀ ਦੇ ਸਿਧਾਂਤ ਫਾਇਦੇ ਦਿੱਤੇ ਹੈ ਉੱਥੇ ਹੀ ਅੰਨ੍ਹਿਆਂ ਨੂੰ ਗੁੰਮਰਾਹ ਕਰਨ ਵਾਲਿਆਂ ਤੋਂ ਸਾਵਧਾਨ ਰਹਿਣ ਦੀ ਅਪੀਲ ਕੀਤੀ ਹੈ। Both the input sentences and the output generated by the Urdu to Punjabi matches almost 80 to 90% is there. It means the output generated by my system in Urdu is quite better, and I am challenging this. Not I'm challenging. Sorry, I'm just pushing it that my accuracy is almost 80 to 82% is there. Another, I want to show you that if I copy this Urdu text from my system and I will go into the translate.google.com. If I write it over and write it Punjabi here, now what Google is doing, he fails on the at the time where the multiple sentences are there. Google works well on smaller sentences. Means I have seen this scenario from the last 2.5 years that Google never works on longer sentences for Punjabi to Urdu and Urdu to Punjabi is there. So I have tested on many times, and this is how my system is working on longer sentences also. Another small example I can give you here as well. Let's go to this part is there. And this is very small sentence is there. And let me just copy it here. Very small sentence is there. And let me just go here, Urdu Punjabi. So you can see that the output generated by Urdu to Punjabi and my system means the Urdu part which I have converted into Punjabi back. Narinder Singh Tomar ne किसानां दे नां अपनी खुली पत्तर विच किहा two times come because above is ki and here is also kiha. So this is about my system, sir, which I have shown here.
Yeah, thank you, Nitin. Over to the participants and Dr. Amba, please, queries from your side.
It's interesting to see that you can translate and you are getting almost same kind of result, and you have demonstrated it on
Hello.
Hello.
Yes.
Will you please
Hello.
put off your mic, Nitin? I think okay. Can you hear me?
Yes, ma'am. Yes.
Hello.
So it's good to see this back translation is working, and Nitin has taken live examples from the BBC website. Today's news he has shown. So this also shows that his system does not depend purely on the corpus, but it also has this rule-based part which is taking care of various other things. So maybe you can tell a little more about your hybrid approach, maybe in 3-4 lines, 3-4 sentences, how you are doing it. Nitin?
Yeah, Nitin. Hello, Nitin. Nitin, are you there? Nitin?
Yes, sir. Now I'm on, sir. Sorry, sir.
Yeah. Please explain your hybrid approach in briefly, please.
Yes, sir. Sir, here I have taken 10 types of domain.
If you have your presentation slide on architecture, can you display and explain?
Sir, sir, I'm so sorry, sir. Give me 10 to 20 minutes. My laptop got scrapped.
Okay, you explain as such.
I will show you the presentation within 10 to 20 minutes again. But sir, here I just want to say that I have taken 10 domains here. More than 1 lakh data I have taken. And the best part is that initially 2 years I have worked manually mapping of Punjabi sentences with the Urdu sentences. I have corrected each and every part so that the translation accuracy can be enhanced. And moreover, I have worked in 3 phases. Initially, I have taken 10,000 sentences in the first phase. There I have checked whether my logic works or not. Then in the second phase, I have taken 50,000 sentences and I have checked that whether my blue score and NIST score has improved or not, and whether the output has comparable with the Google or not. So in the third stage, I have taken around more than 1 lakh sentences. There I have found that accuracy has increased to 82%. And there I finalized, I have checked it with all the faculty members also. So this is how it works, sir. In hybrid approach, statistical approach comes with the collection of data. And in case of rule-based, I have designed various rules where out of vocabulary words are being handled or some other task can be handled. Yes, sir.
Okay. Yes. Yes. So if we get the time, you remain prepared with the presentation architecture slide only. So if you get the time, we will trouble you again. Fine?
Sir, sure, sir. Sir, I'm sorry, so sorry. I just do it.
Okay. Please stop sharing the screen so we can move ahead with the next demonstration by Kanwaljit Kaur, design and implementation of anaphora resolution for Punjabi language. Kanwaljit Kaur, please share your screen.
Good afternoon, everybody.
Yeah, good afternoon. Please continue with the screen sharing.
I'm unable to share because Nitin sir has not yet stopped sharing.
Yeah, actually, I'm working on that, sir. My laptop is just
what you can do is you can just leave the if you can leave the meeting, then screen sharing will go away and then you can rejoin.
Okay, sir.
So you can share, Kanwaljit?
Yes, sir. Yes, good afternoon, everybody. I'll be demonstrating the implementation of anaphora resolution in Punjabi language. I won't say I have completed. I'm still working on this. And let me demonstrate the small work that I have done so far. So the very first thing that I'd like to represent is what is anaphora resolution. So anaphora is a form of reference in which a word, mainly a pronoun, is used instead of the mentioned item, and which is basically a noun or a noun phrase, and the entity to which it refers is the antecedent. So let me give you an example. In Neha always took her camera with her. So her is referred to as the anaphora, and the entity to which it refers, that is Neha, is an antecedent. So this is the terminology in the project, and I'm working on anaphora resolution, which is the process of determining the antecedent of an anaphora. And this is the framework which I have used. The very first thing that you need to do is pre-process the simple text. We have to extract the pronouns and the possible noun phrases from it. And then we pair up the various anaphora with the candidate antecedents. And then we apply some computational strategy so that we choose the correct antecedent. Now the computational strategy, number of strategies are available, rule-based is there, score-based is there, but I'm using the machine learning approach. It is the statistical approach. So after applying the machine learning approach, we will choose the most likely candidate and then the system is evaluated. Now let me represent the small tasks that we have performed. This is the Punjabi, simple Punjabi text that we have chosen for the work. Now to perform anaphora resolution, we have to and apply machine learning approach. We have to extract features from this text. Now you can't directly extract the features. You need to have various apply various processing over it. So to extract the features, I have applied the shallow parser that is provided by IIIT Hyderabad. So text is processed and the output of the shallow processor is in Shakti standard format. It has applied various morphological features to it and POS tagging has been done. So at least I'm getting the various grammatical features on it. Now the next part that I have to do was to perform machine learning. I need to link the anaphoras with the corresponding antecedents. So here I'll be looking for the PRP tag because anaphoras are mainly the pronouns. So this is here. This is the PRP tag is here. This is the pronoun. So I need to link it with the correct antecedent. So now in Punjabi, not much features are available that can give me animacy or they can give me named anti-recognition or pronoun type. So in this, I have manually annotated the corpus with these features. So all the NPs, they are also manually annotated with various features. So, and I have linked the pronouns using the ref tag with the corresponding correct antecedent, that is noun phrase. This terminology refers that one is the same sentence one. This is refers to phase NP2. So this is the pre-processing that we have used, and after the file is pre-processed, we give it as input to the program that we have created, and the features are extracted from it. So when I give input as input to this program, I'll extract the features and then I can apply machine learning approach. Now the features, they have been extracted from this file in this format. The various features that we have used are the agreement features, distance features, named entity recognition, animacy, pronoun type, and this. So this is basically represented as a classification problem. So the features are extracted and then they are model is created for this, and the output is again generated in the form of a CSV file. That is how many have been predicted. When I applied the naive Bayesian classifier, I could just get an accuracy of about only these much correct matches were there, and then I also try to improve the accuracy by using boosting algorithm. In that case, it rose to about 80%. So these are the correct matches. So I am still to represent it in a proper way. This is just the representation of the work that I have done till now. Thank you. And I could show that the accuracy. This is the result. I have worked on a single file only that contains about 400 pronouns. Thank you all.
Yeah, okay. Thank you, Kamaljeet. I think I know that your work is still under progress and a lot of work has to be done, but still you have tried good work. So, Professor Amba Kulkarni ji, any queries on that or any other participants, please?
I am interested in knowing which all features you have used.
Yes,
You
sir.
said named entity recognition and animacy. Are these the only two features which you have used?
No, ma'am. I have used the agreement feature, gender, number, and then the distance features, that is number of sentence difference between the correct anaphora and the antecedent, number of noun phrases that are coming up, number of connectives that are there, so, and pronoun type.
Yeah.
These are the features that have used.
And under named entity, what all subclassification you used?
Yes, ma'am. I have used the features that is buildings, name, person. Okay, I have maintained
organization.
all features. Yes, I have used the as part of the SPACI library supports these features. So person, anomalies, religion, product, law, percentage. These I have used.
Okay.
Yes.
Good.
And I think that will be the first work in anaphora in Punjabi language.
Okay.
So no one has started for Punjabi.
So have you also looked at the error analysis? Have you done any error analysis?
Ma'am, I'm still working on it. I can't say that I have done fully. I have worked on one file and the results are just in front of the screen only. I have.
So, how many sentences are there? You said 400 and odd anaphora.
238 sentences, ma'am. I have just worked on this part because manual annotation is done and it takes quite time to link out pronouns and the antecedents.
Yeah, fine. Thank you.
Thank you all.
Okay, Kamalji, good work. Keep it up and complete the work. And in next icon, you will be presenting the full demonstration for your full system. Fine?
Sure, sir. Thank you, sir. Thank you.
Okay, okay. Thank you very much. Now I call upon Arpana Prasad for opinion mining system for pre-processing Hindi text for home remedies domain. Miss Arpana Prasad.
Yes, sir. Yes, sir.
Neeraj Sharma and Shubhangi Sharma. Yeah, Arpana Prasad. Yeah, please.
I have to share my screen.
Yeah, Kamalji, please stop sharing your screen.
I'm working on it.
Yeah, you can share, Arpana.
Yes, sir. One minute, sir.
No issues. No issues. Take your time.
Sir, actually, I'll share my PowerPoint first.
Yeah, okay, okay, fine, fine. No issues. Be comfortable.
Yes, sir. Good afternoon, everybody. Myself, I'm Arpana Prasad. I'm sharing my demonstration on opinion mining system for processing Hindi text for home remedies domain. And I want to demonstrate the lexical resources in Hindi developed for an opinion mining system. The language for the text is Hindi and taken from weblogs. The text demonstrating the cause and effect relationship between entities, food and health issues. The sample text is on the screen. That शोधकर्ताओं का कहना है कि चावलों को मास्क या सोयाबीन के साथ लेने से खून में चीनी का मात्रा पर असर पड़ता है. So similarly, there is one more text that दही के लगातार प्रयोग से लाने से आंतों के रोग और पेट की बीमारियां नहीं होती और कई प्रकार के विटामिन भी बनने लगते हैं. The computational requirement for this is an algorithm that extracts domain-specific related entities of type food and health issue in the form of word or phrases from domain-centric text taken from Hindi weblog, a polarity and strength classification algorithm that classifies the association between related entities into predefined polarity classes, that is positive or negative, and determines the strength of the association into strength type, medium, or strong. So I'm just sharing the output since I have not developed any interface as such. There's of course one probing interface I have developed, but this is like the output of the algorithm which uses the lexical resources. Like you can see the first text, शलगम, शलगम को पानी में उबालकर पानी को छान लें और शक्कर मिलाकर पीने से गला ठीक होता है. Now the algorithm identifies that the health problem or the body component on which the food item has effect is gala, and the food items that when consumed in combination, it has identified that pani, shakkar and shalgam. And the association type it has identified is plus. That means that the food components have to be taken in association, and the polarity which it has derived is positive, and the strength of the polarity is medium. Now I'll draw your attention to the second text. It is again the food item which is derived from the text is adrak, आधा चम्मच अदरक का रस आधे आधे घंटे के अंतराल में पीने से गला ठीक हो जाता है. तो इसमें the health issue or the body component identified is gala, and the food item is adrak or adrak ka ras. But then it is like the food combination association is or, because it's like not and adrak and adrak ka ras. So because of the how it is derived from the text. So then the third one, there is only one particular food item which is identified, that is pyaz ka ras, and the health issues identified is khasi, pet dard, neend, kashto. Because kashto is in my database, so it has taken the kashto as a part of it, a part of the health issue. And then in the fourth case, there is a strong polarity between khasi and shahad and adrak. So it shows an association polarity of positive association polarity. The strength of polarity is strong, and the association type is and relationship between the food items, that is shahad and adrak, and the health issue identified is khasi. Similarly, there is there is a negative association. There are some sentences with negative associations, like the health issue identified is cancer, bimariyan, and the food identified is sharab from the text. ज्यादा शराब की लत कैंसर जैसी घातक बीमारियों को न्योता देती है. So and the food combination is not applicable since there is only one particular food item, and the association is negative of medium strength. Similarly, now the next sentence shows a strong association between the food items between the food items and the health issue. The food item identified is tel and dhumrapan. तेल और धूम्रपान, because the text is यदि आप हृदय के स्वास्थ्य को गंभीरता से लेते हैं तो एक बात सदैव ध्यान से देखें कि तेल व चिकनाई युक्त पदार्थों का सेवन तथा धूम्रपान हृदय के परम शत्रु हैं. So the text which is identified is for the food item is tel and dhumrapan, and the health identified is hriday, and the relationship between the food item is or relationship, hence and there is a negative association of strong polarity. Similarly, the next sentence says coffee, chai, madira, मांस, तंबाकू, चॉकलेट, पेस्ट्री या मिर्च मसालेदार की सेवन करने से यदि इसके खाने से अम्लपित्त की समस्या हर बार होती है तो अच्छा यही होगा कि आप इसका सेवन बहुत कम करें. Now this is a medium. The polarity derived is negative, but the polarity type is medium. The strength of polarity is medium. The association type between the food items is or, means that any one of these has a negative effect on the health issue, that is amlapit. And then the last sentence is machli और दूध को एक साथ लेने से. Now machli और दूध, they are talking about having it together. साथ में खाने से कोढ़ हो जाता है. Now कोढ़ is the health issue which is affected, and machli and दूध is the food types, and the association is and it is a medium polarity association. So there are some lexical resources which I have developed because this was an area where there was no corpus as such available, and this was a field which was related to opinion mining. A lot of work had been done related to movie reviews and product reviews and simple words. But here we were talking about finding the polarity of association and strength of polarity. So there were certain, especially there was no lexical resources related to the domain. So I, with taking into account word sense disambiguation, I have identified 2,870 unique food items and 254 unique food adjectives. That is like Kali chai. So for chai, we use the word Kali with it, or Kali tulsi, and garam pani. So, and similarly food components which I have identified, like there are certain times when it's not the whole, like aam ka beej is important for a particular health issue. So beej is the food component. So I have identified 293 words and phrases which are used for food component beej. And health problems which I have identified is 2,499, and body components is 1,817. Rather, there are more which are identified, and they are just the variation of the spellings which are there. But these are like with correct spellings. These many are identified, plus the variations are also identified. Now, these are the sample of food items which are identified. And I have also mapped them to the synonym sets which are available with Hindi WordNet, as well as there are certain food items for which the synonym sets are also not available. So the word sense disambiguation was a very big task in this, because like a word muli is used for chipkali also, it is used for river also, and it is a food item also. So that is one big challenge which was there in identifying each and every text. So for that purpose, I used the word meaning clause, which is word meaning semantic information, which is there in Hindi WordNet. And then these are the examples of food adjectives. These are examples of food components. Like we can see ark, ira, chilka. And these are the examples of health problems. When I say health problems, it is like even, it is talk about even mental problems I have included, because food has got impact on mental problems also. And when I talk about body components, it is not only the organs, it can be any part of the body composition, like blood, it can be saliva, it can be urine, anything. So all those, and with their, as far as possible, I have tried to take the variation of the spellings, which was, because in weblogs, there is like, when any text is added on the weblog, there is no screening on whether it is linguistically correct or not. Sorry, I'll just go to the previous. These are I have identified around total 25,000 sample records for negative polarity bearing phrases. Now these phrases are identified from the text which were appearing from weblogs, on Facebook, on different medias, plus from the books I have taken, because the text which is available on the books is also candidate to weblogs. So as of now, there's not lot of text which is available on the weblogs, because there's a lot of repetitions. That's what I have seen, that people have copied the text, and or they are like I had for 2 to 3 years I was collecting the text, and I was finding that the text was being reposted again and again on the through the RSS feeds. I was getting the text which were reposted. So I took some candidate texts also. So these are positive phrases, sample of positive phrases. And I have used trigrams from these phrases, and to do the polarity classification. And I've used the Naive Bayes algorithm using the trigrams from this, because if the trigrams would take unigrams the word sense ambiguity was not resolved using the unigram words, and even with the bigram words. And if I took more than trigrams, then my feature phrases, all the feature phrases would not have that less number of words. So I have ensured that when I have developed these feature phrases, I have ensured that any like samasya ko hal kiya. So the trigram which is developed from here is samasya ko hal and ko hal kiya. So both the components of the trigrams, they show the same polarity. So the polarity is not changed if I take a subset of a trigram from. So whatever phrase I have identified in such a way that the trigrams forming from these phrases have the polarity which I have specified for the feature set. And I just want to tell you that around 50,000 trigrams are generated from these, and these are unique phrases because I went through a lot of text, but finally these are the phrases which were getting repeated, which were conveying the sense of polarity for a particular sentence. Similarly, for strength of polarity, those same phrases I have again I revisited, plus I added few more phrases which told the strength of the polarity, whether it is strong or it is less strong. So these around 14,000 total these polarity phrases I have identified. I had started my work by initially developing a corpus. I started taking the text documents of text, which ran into thousands, but then I was working only on the sentences. The granularity of analysis was sentence. So just to understand the computational requirement, I developed a small corpus and got it annotated manually. So it was a very, very hard work which went into it, because the annotation, like if you can see, the original text is चिकनाई वाले खाने या खरबूजा खीरा के तुरंत बाद पानी पीने से खांसी जुकाम हो सकता है. I have stemmed this text using a online. There's a stemming tool which was Linux-based and stemming tool which was available. And part of speech tagging, I have a tool I have used from IIT Mumbai. I actually compared 3 tools, and from those tools I realized that one particular, like the tool which valid part of speech tag from the corpus, I identified that too. And then I formatted I had given a guideline to the annotators, and I accordingly they annotated. And of course this the annotated food annotation which you can see, which talks about the adjective and the component of the food item, it is just for computational help that I have formatted it in this way, just to understand the computational requirement. But since it is a resource which I have created, so I wanted to share it here. So these are the sample of, there was a very skewness of data, like about, I can say 70% of the data which was available on the weblog talked about the positive effect of food item on the health issues, and only 30% talked about the negative effect. So for the negative features, I had to refer to the books and other resources, images and all a lot. This is my sample records. Now, any OMS is supposed to give some outputs in terms of summarizations. So this is an example of a probe. Like I wanted, this is a probe which I wanted to know the combination of food items which are must not be consumed together. So from the data which is collected, and from the, I have developed a database which can handle this kind of a probe, and it specifies like phal and chai and all the food items which are affecting the body component, or the affected like pachan kriya, pachan, pak, karam. So all these words, so this is identified. And we can see then the second thing that food set, phal, far, prasoon and coffee, if they are the two, if they are taken together, they will again be very not be good for pachan kriya, pak kriya. And then in the third example, you can see the bhojan and jal pani. If they are taken together, they are bad for charbi, pet, med, vasa, pist, alka, shupra, fat. So all these are this information is coming from my synonym sets. Similarly, there's a probe, like this kind of a probe can be done, like what is the effect of negative effect of having dahi. So these are the health issues which are negatively affected with dahi, that is madhume, madhuprame, and there are all the synonyms of madhume is also specified, so that anybody who wants to know what is the negative effect of dahi.
Can you wind up please fast?
Yes, sir. Yes, sir. So I think, sir, I am done with my presentation.
Manpreet Singh Lahal, please, can you mute yourself, please? Manpreet, can you mute yourself? Manpreet Singh Lahal, please, can you mute yourself? Okay, so I open the panel for discussion. And Dr. Amba Kulkarni ji and other participants, please ask the queries. Are there any queries, please? Okay, so now we move ahead with the next presentation. I invite upon Toby Reed for the demonstration of a literature-based discovery system based on ontologies, semantic filters, and word embeddings for the Raynaud disease, fish oil rediscovery. Toby Reed, please.
Hello, I'm here. Oh, that's the wrong one. That's not one. There you go. So good morning, afternoon, where you guys are. Because of COVID, we can't get to the lab to show the device, the system live. So what I'll do is I've shared my screen and I'll play the video we recorded previously, and then I can go through any questions after. That all sounds good to everyone. So I've shared my sound, and I'll just play that for you now. Hello, and welcome to a demonstration of a literature-based discovery system based on ontologies, semantic filters, and word embeddings for the Raynaud disease and fish oil rediscovery. I'm Toby Reed, a junior software developer at Streets Heaver Healthcare Computing and a previous Masters by Research student at the University of Lincoln. I have been supervised in this project by Dr. Vassilis Cutsuridis from...
Can you make the audio a bit louder, please?
Of course, can. I don't know if we... Oh, just a minute. Streets Heaver Healthcare Computing and a previous Masters by Research student at the University of Lincoln. I have been supervised in this project by Dr. Vassilis Cutsuridis from the same institution. In this research that allowed us to revisit an older hypothesis, we decided to use as many new deep learning methods to try and see if we can get the same results, if not better, than the previous statistical natural language processing methods utilized by previous researchers such as Mark Weber. What you can currently see on the screen is the first step taken to generate our word-to-vec model, the reading in of compressed data from the disk into memory. This free text, which was initially taken from a PubMed database, is then trawled through for any bigrams and trigrams which are found, and then they replace the corresponding text with the. Now we have taken our free text and generated the bigrams and trigrams, and this has been transformed. The next step taken is the generation and saving of any so-called Raynaud's terms. These will be used further in the research, and you will see why when. Once the free text has been transformed to include its bigrams and trigrams, this text is then plugged into a brand new word-to-vec model with optimized parameters which we found through another area of research we undertook. This model is then trained on the text, and on completion of this training, The phrases with the closest cosine similarity to the aforementioned Raynaud phrases are taken and saved to a list. Once this is done, what we have is we have a saved list of as many of these words which have been found to be relatively similar to the Raynaud's phrases. As you can see, we have words here like erythrocyte elongation, we have cytoplasmic vacuolization, and many, many others. Some of these are going to be useful, some of these are not. So all we now do is we then actually will process this list using a free-to-use
You are not talking. You have to be relaxed.
Take words like these, free text, and convert to what that means is it has its own semantic type which we can then filter from later. What we have here is a same list of mapped words combined with what happens here is, as I mentioned, when those interesting terms as such are found, we then map them to metamap ontologies. What this does, as I previously mentioned, is it gives each term a semantic type, such as biologic function, body locational region, body part, organ component, so on and so forth. I want to confirm this is not a comprehensive list, but what it is it allows us to filter it down to something potentially interesting. This semantic filter list was taken from the same, well, I say the same, but similar work from Mark Weber et al. In 2001. And it allowed us to really look at that list and automatically kind of get rid of what is, guaranteed, but what was most likely to not be useful. So, what I hope you have seen in this is a system that can be used in many different ways to potentially improve and bring the cost down in drug discovery, which at a time is more important than ever. Thank you all for listening, and please do get in touch with any and all questions you may have about the work, and do stay safe. Thank you. Bye-bye.
Okay.
Yeah, thank you, Toby. It was a very good presentation. Any queries, please? Dr. Amba Kulkarni ma'am and other participants, any queries from your side for Toby Reed? Okay, thank you, Toby Reed. Thank you. It's a very marvelous product. Thank you for joining and demonstrating. So now I call upon the last participant, last demonstration for today by Dr. Prateek Aggarwal ji on a Sanskrit to Hindi language machine translation system using rule-based system. Dr. Prateek Aggarwal ji.
Yeah, thank you, sir. So,
thank you. Welcome.
So, may I share my screen?
Sure, please.
So, very good morning, good afternoon to everyone. I'm Dr. Prateek Aggarwal. I am working as postdoctoral researcher in the University of Klagenfurt, Austria, and also I am associated with the lovely professional university as associate professor in computer science engineering over there. So today my topic is a Sanskrit to Hindi language machine translator using a rule-based method. So
hello. Yeah, please continue. Sorry. Please continue.
Yeah, am I audible, sir?
Yes, very much.
Yeah. Okay. So before going to start my demonstration, I just give you all the brief about what is this all about and what are the prerequisites that I took. So in this case, I worked on total 5 tenses. In Sanskrit, we call it as Dhatu, and they are for active voices only. So in that case, like present tense means like lat lakar, lot lakar, lung lakar, lit lakar, and bidling. So these are 5 different tenses on which I worked, and I prepared some grammar rule for each verb form, as well as I prepared the grammar rules for the noun forms. So there are different types of nouns depending upon the ending of that syllable of each word. For example, if I talk about the word Ram, so Ram is ending with the vowel A. So means we call it as ending with A, akarant. So there are different types of noun forms like akarant, ikarant, ukarant, jakarant. So there are different 15 types of forms, standard forms of these noun forms on which I worked and prepared the grammar rules for that. And I followed each and every single phase of natural language processing, starting from the phonology, morphology, lexical analysis, then syntactical and semantic analysis. After that, discourse integration, then pragmatic analysis. So one by one, I will explain each and every phase, how does it work, and how I incorporated in our work in this demonstration. So there are approximately, if I talk about for each type of tense in active voice, there are total 9 different forms. For example, like there are three we say like genders. So as well as three counts: ekvachan, dvivachan, bahuvachan. 3 types of noun type like pratham purush, uttam purush, madhyam purush. So based on that, total 9 different words can be formed for each tense. So in total, if I talk about the verb form, the number of words that I trained is 9 multiplied by 5. So it is approximately 45 rules for the active voices that I tried for the verb, and for the shabdrup, that is the noun form, there are different karaks like prathama, dutiya, tritiya, chaturthi, panchami, shashti, saptami, sambodhan. So 8 with 3 counts like ekvachan, dvivachan, bahuvachan. So it would be total 3 multiplied by 8, that is 24 multiplied by 15. So it is approximately 500 rules that I formed for that. So one by one, I will explain each and everything. How does it work? So my basic primary objective to develop this tool was just to make the people connected who are very much comfortable in Hindi language, just connect them with the Sanskrit basics also, and just try to encourage them and motivate them to learn Sanskrit more and more. So I developed this tool on Java and NetBeans. So here I am going to start. This is the tool screen, which contains total 9 different panels. In 9 different panels, if one by one I will explain this. The first panel of anything that you are writing in English, it would be transliterated into the second panel where it is written Sanskrit. And in that, I also provided the virtual keyboard option. If anybody is not comfortable to write it in English and transliterate it in Sanskrit, then directly he or she can type in using virtual keyboard also, as we see in net banking also. So in the similar pattern, we incorporated the virtual keyboard option also. So the first panel is responsible for the transliteration of any particular term, and here help button is there. The role of this help button is just to provide the help, which particular letter is responsible for which particular letter in Hindi or Sanskrit. So this is the help which is provided over there, and if anybody will type KA, it means the transliteration would be K. If anybody is typing KH, then transliteration would be Kh. So it is like that. Other than this, if I talk about these are different alphabets which are actually mapped over here, and the third phase, the third panel is about the stemming, which is the second column, first row. So in that stemming, anything which we have written in that second panel of first column, everything would be stemmed over there, just like Sandhi Vichhed, as we do. So in that Sandhi Vichhed, what will happen? All the suffix and prefix which are over there and which are responsible for different grammar rules, they will be split out so that the root word of that particular Sanskrit word can be identified. And after that stemming, in the second column, second row, the semantic analysis is there. So once the root word as well as the suffix and respective prefix are separated out, then the grammar rule will be taken place, and as per the semantic analysis, the translation of those Sanskrit words into Hindi would be taken place into that middle one panel. And once we will do that, then there is in the first column, last window panel, there is a Vyakhya explanation. So whenever you will click on any of the Sanskrit word, you will get the entire explanation along with the grammar information, which particular vachan it is, which particular tense it is, which particular gender it is, everything would be there to you. So that anybody who is not very much familiar with the Sanskrit language, but he or she knows Hindi well, they will be easily able to understand how does it work and what does the meaning of each word. So once the semantic analysis is over, then the next job is just to perform the discourse integration. In discourse integration, we took place the discourse integration because in this demonstration, we also embedded the extra approach, that is to generate the title of that story which is being translated from Sanskrit to Hindi. So for this, we require some help to identify. There is one approach that we used to generate the title of the story. In that, we were classifying the number of adjectives, number of nouns, number of pronouns, means every parts of speech element was counted, and based on that we did perform some analysis and we generated the title of that story. So for which we require to make each and every sentence independent from the other sentence. Because of that, we perform the discourse integration. So for example, there are two sentences. I say that Ram goes to school and he is very intelligent. So here he is referred to Ram. But to identify that how many times Ram is referred in this couple of in this pair of sentence, in that case we need to make it discourse. We need to discourse it from the other sentences. So in that case, Ram becomes Ram is present in both the sentences. Ram goes to school and Ram is intelligent. So once we will just convert it into discourse integration, now he is replaced with the Ram. So pronoun, all the associated pronoun would be suggested with the required noun in the discourse integration phase. And last is the pragmatic analysis. In that pragmatic analysis, which is the third column, first window panel, in that pragmatic analysis, all the sentences which are semantically analyzed and also discoursed from the other sentences, they will be examined if the entire meaning of the sentence is correctly defined or translated or not. If it is not, then pragmatic analysis will take place and it will make the changes so that the entire translated sentence will be meaningful. So there is a minor difference here in semantic analysis and pragmatic analysis. In semantic analysis, we are translating the words one by one, while in pragmatic analysis, we are examining the meaning of the entire translated sentence, whether it is semantically correct or not. So once this phase is over, then next job is just to tag them. So for this, I used a ready-made tagging tool, that is the RDRPOS tagger, which is developed by the scientists from Vietnam. So I use their tagger to tag each and every parts of speech element in our translated word. And once that tagging is performed, we used some algorithms. We developed our algorithms to generate the heading or the title of that translated story. So now one by one, I will explain it. How does it work? So for example, so for example, here virtual keyboard is open, and anything that you are typing over here, it will be in the editor. So here I am typing like Anilaha Jalam Pivati. So anybody who is not actually who is very new, okay, in writing the text from English to Sanskrit in transliterated mode, he can type it like this. So here Anilaha Jalam Pivati, the reverse transliteration in English is already done. Now you can directly type it in the first window panel like Prateekaha Vidyalayam Gachati. So even there are both the facilities. You can directly type it, or you can take the help of virtual keyboard also. So there are some couple of sentences which I wrote over here, like Seh Kalmen Likhati, Rama Kalmen Likhati. So I intentionally keep these two sentences which are very similar, like Seh Kalmen Likhati and Rama Kalmen Likhati. But there is one major difference, that the gender of both the words, both the sentences are different. So the subject in the first sentence, Seh Kalmen Likhati, it is masculine gender, while Rama Kalmen Likhati, it is feminine gender. So because of this, in Hindi, the meaning would be changed. So Aham Darsham Pashyam. Yeah, so once it is done, now next job is just to perform the stemming, the Sandhi Vichhed. So for this, it is clicked like stemming over there. So each and every word is now separated out and split out between the root word and associated suffix, or in some cases, if any prefix is there, then it would be separated out like this. Now, once it is over, then meaning will be performed in semantic analysis. So it is generated. So Ram ne, it is as per the grammar rule which we defined already. So Ram, here you can see like in the third sentence, Seh Kalmen Likhati. So the appropriate translation in semantic analysis is वह कलम से और कलम के साथ और कलम के द्वारा लिखता है. While for the next sentence, it says Rama ne kalam se kalam ke saath aur kalam ke dwara likhti hai. Now the important thing is, like, even the Sanskrit word is same, likhati, but because of the grammar rule and the analysis at the semantic level, the meaning of likhati is different in both the sentences. In one sentence it is likhta hai, in another sentence it is likhti hai, depending upon the gender. So once it is done, now if I click on any of the Sanskrit word, it will give the explanation in this Vyakhya window panel that Anilaha is singular form, Ekvachan, Vibhakti Prathama, Arth is ne, Karta ne, Karm ko, like this. Shabd Prakar is Akarant type, and Ling Prakar is pulling masculine. Similarly, if I click on any of the other word, for example, Pivati, then it will give the explanation. Pivati is what? The meaning is earth, meaning is Pina. Shabd Prakar, it is Piv word that we are using, Piv Dhatu. Shabd Prakar is Kriya, it is Dhatu Roop, and Dhatu Roop type is Lat Lakar, it is present tense. Purush is Pratham Purush, Bachan is Ekvachan, and earth is Tahe, Tihe, Tehe, like this. So this is the entire explanation of each word, so that if anybody who is very new to Sanskrit, he can directly check it and understand how does it work. And he can also learn, if he is comfortable in Hindi, then he can learn Sanskrit also in a very user-friendly way. So once it is done, now the next job is just to perform the discourse integration. Yeah, here the important thing is like Rama, because Rama is feminine gender, it is striling. That's why the meaning of likhati becomes likhti hai, not likhta hai. So this is linked with the subject, appropriate subject and its gender. So these kind of rules were defined over there. And once it is done, then next is discourse integration. Now, if we compare the discourse integration output and the semantic analysis output, we will find, for example, the third sentence, Seh kalmen likhati. So here, Seh is referred to some noun. And what is that noun? So there are some algorithms which were performed, and based on that, it identifies that here, Seh kalmen likhati, वह कलम से लिखता है, वह is referred to Prateek. So अनिल ने जल को पीता है, in discourse integration प्रतीक ने विद्यालय को जाता है, प्रतीक कलम से, कलम के द्वारा और कलम के साथ लिखता है. So here we can see like now this pronoun he or वह is replaced with appropriate noun, that is Prateek. Similarly, in the sentence where another pronoun in feminine gender, sa Prateeken seh phalam khadati, that is the third last sentence. So here this particular pronoun is replaced with the appropriate noun, that is Rama. So here we can say like in the semantic analysis it is written that वह प्रतीक से प्रतीक के साथ प्रतीक के द्वारा साथ फल को खाती है, while here it is written like Rama प्रतीक से प्रतीक के साथ प्रतीक के द्वारा साथ फल खाती है. So means it is simply replacing the pronoun with the appropriate nouns which are available in the story. Once it is, sorry. Yeah, so once the discourse integration is done, now next job is pragmatic analysis. So there are some analysis done at the pragmatic level where it will tell which particular we say like Hindi word is appropriate to make the meaning of the entire sentence. So here there were multiple choices with the third sentence or like वह कलम से कलम के साथ और कलम के द्वारा लिखता है. So here I initially system doesn't know at the semantic or discourse integration level whether the appropriate word is से और के साथ और के द्वारा, because in शब्द रूप like तृतीय विभक्ति कर्ता ने कर्म को कर्ण से कर्ण के साथ कर्ण के द्वारा. So there are three choices, but up to this sixth panel system doesn't know. But in the pragmatic analysis it makes it checks the semantic of the entire sentence and which one is the most relevant, it takes that out of here. So we can say like रमा कलम से लिखती है. Now कलम के द्वारा और कलम के साथ, both the options are negligible here and we are taking only say. So this is the final translation of the appropriate sentences which we used in the Sanskrit. So this is the Hindi translation, and additionally we extended it by performing some tagging over here. So in that tagging it will use the parts of speech tagging, where this is a third-party tool. We didn't develop the tagging part, so we simply referred them. So different types of like proper noun, noun, symbol, main verb, auxiliary verb, these are associated over there, and based on our algorithm, we generate the title of these 4 or 5 sentences, that Prateek or Kalam. This is one appropriate heading of these translated sentences. So this is our work which we did. So
yeah, thank you, Dr. Prateek. Prateek, it's really exhaustive work that you have done, and it is a very good presentation. Over to the participants and Dr. Amba Kulkarni ji. Any queries, please?
Yeah. So thank you, Prateek, for the presentation.
Thank you, ma'am.
There were small corrections. First, let me tell you about the small corrections. Dhatu Rupa, you said actually Dhatu Rupa is the actual form, and the Lakara that you use. So for tense, instead of calling Dhatu Rupa, I think better you call it Lakara.
Okay.
Then for noun forms also you use the word Shatru. Actually, it's the Subbantas, not the Shatru Pratyay. Shatru is a Krudanta Pratyay. Okay, so these are just small things which I thought I will just tell you about the correction. That's it. Now, coming back to your work, well, how big is your vocabulary?
In that case, ma'am, this is purely grammar-based thing. So as I told you, like we worked on the active voices only. That is in.
So that is fine. No, what I am asking is how big is your noun database and verb database?
That is, I am telling you, for noun database, the ending letters that I am identifying, they are 15. Akarant, ukarant, ikarant, chakarant, jakarant.
And for all the three genders.
For all the three genders, so they are approximately 500 in numbers. Okay, and if I talk about the verbs, so in that verb, I focused on 5. We say like tenses, if I'm not wrong.
Yeah,
so
those 5 lakarat, and how many verbs are there?
No, it is not depending on the words. I'm telling you.
Verbal roots.
It is depending upon the grammar rules. So for example, either you are dealing with the pat dhatu or you are dealing with gam dhatu, it will work accordingly. So there is one grammar rule for pat, there is same grammar rule for gach. Gachati, gachata, gachanti, or it is the same for pivati, pivata, pivanti. So there is no difference. So what my job was to work more and more at the pragmatic level, so that it can identify.
Just a minute, Prateek. See, I'm not asking about the grammar rules. I know about the paradigms. You are talking about the paradigm types, which are 15 or whatever. Okay. I'm asking you about the size of your lexicon. Right?
Yeah, in that case, ma'am, I'm telling you, like these are the general rules. So, for example, total 9 rules for each tense is there. And
let me clarify. No doubt you have coined the rules. So when you are actually translating, right? So yes, word by word, if we talk about, so Sanskrit corresponding to Hindi. So such type of dictionary we are talking about. How many such type of entries are there in your lexicon?
45 standard rules for the verbs. So that I am telling you, if either it is piv dhatu or it is gam dhatu or it is pat dhatu, it will only identifying the stemmed root word, and accordingly it will react. It will translate accordingly. So that's why the stemming is performed. Ti taha anti. Si tha tha, ami ava am.
Question is not about the morphology or the stemming. Question is about the translation. For translation, how big is your dictionary?
I'm telling ma'am same thing in that dictionary.
You need to have an entry for pib separately and entry for lik separately, because lik is to be translated as likhna and pib is to be translated as pina, gum is to be translated as jana. For this you cannot have just a rule, you need to have a bilingual dictionary.
So for you mean to say, like, for each word you are asking about, for each word how many verbs I have taken into it? Yes. So there are approximately 120 verbs that I am defining. For example, piv means pina, gach means jana.
Okay,
so these are 120.
Okay, fine.
For the verbs only.
Okay.
And there are 45 standard rules, and now we are combining them and we are performing some analysis and applying our algorithms.
Okay.
Similarly, there are some other nouns also. So in that case, for example, Ram means Ram, but there can be some pronoun like Seh means Veh. So there are some other dictionaries for other type of parts of speech words also. So they are approximately 170.
Okay.
Those words, yeah.
Thank you very much. And for deciding the for pragmatic analysis, what kind of knowledge you are using to decide whether it is to be translated as, say, kalam se kalam ke dwara and kalam ke saath, instead of these three you disambiguated as kalam se. So what kind of knowledge you are using for disambiguating this?
In that case, ma'am, we are simply making the checks, means before that word, which particular word is there, which type of word is there, after that word, which type of word is there, and then we performed some rules, and those rules were applied over there.
Okay.
Yeah.
Thank you.
Thank you, ma'am.
Okay, thank you very much, Dr. Prateek. Any more queries from any participant? Yeah, Dr. Rajeev.
Yes, Vishalji, then I think this is the last presentation, is right?
Yeah, it is the last presentation, yes. Okay, then thank you very much. I'm really thankful to all the participants, all the presenters, and the session chairs. Yeah. All the session chairs, Dr. Gurpreet Singh Lahel, Mr. Sanjeev, Mr. Neeraj, Dr. Sanjay Dwivedi, Dr. Amba Kulkarni ji, Dr. Rajeev. So I'm really thankful to you, and this is, Mr. Vishwajit is there. He want to speak something. Yes, please.
Yeah. Thank you, Dr. Vishal, for the opportunity. Actually, I'm having a one very little doubt from Dr. Prateek how he is deriving multiple words from the dhatu root based on the Paninian rules or something else.
These are simple Paninian rule.
Okay.
Okay, so thank you very much for joining us. And if anybody requires, we have recorded the session as well. So we'll be sharing the recorded version on the YouTube as well. So thank you very much on the behalf of Dr. Asif, because he is busy for tomorrow's sessions. So on the behalf of Dr. Asif Iqbal, I am really thankful to all of you for joining virtually over here during the ICON first day pre-conference demonstration session. So thank you very much. Good day. Bye-bye. We are closing the session right now. Thank you very much. Bye-bye.
Thank you.
Okay, thank you. Thank you.
Thank you, Dr. Rajeev. Thank you, Dr. Amba ma'am. Thank you, ma'am. Thank you, all the participants.